Right, I think I'm here. How's it going, everyone? My NAS is doing a backup, so you might be here clicking away in the background. Right. Tablet's going off. I turned the tablet on a while ago. It's sorting itself out. Okay, so who we got here? Thomas, David, Wilhelm, and Ian, and Armando. Right. Still trying to wake up. I got a bit thrown this morning because not only was it a relatively early morning, I woke up and found that my alarm hadn't gone off. So, well, kind of hadn't gone off. I looked at the clock. Oh, it's 20 to 8. Damn. And then I looked at my phone and it says 20 to 7 because daylight savings time kicked in this morning. Hey, bit of hard rest. So yeah, that threw me a little bit. So I sort of got up in a panic thinking, oh no, I'm going to be late. And then I realised actually, no, I could have stayed in bed for another half an hour. Anyway. I love the way YouTube tells me that I'm live. Like, it notifies me that I've gone live. It doesn't notify me when other people go live. Only me. So the one person doesn't need to tell. It does tell. Anyway. I did a review on something yesterday. Well, recorded footage for a review yesterday. It was interesting little piece of gear. Interesting software. It'll be out in a few weeks. That's going to be looking at my timelines here for when I can actually publish it. Probably 25th April, 24th of April, something like that. It will come out. I've got it here yet and everything. I only recorded it yesterday, so yeah. You got a notification, great. Hey, Jonathan. You do as well, David? Cool. No, at least notifications did go out, I suppose. But just find it funny that I don't get notified of other people's live streams, only my own one. It's just annoying. Anyway, at least mine goes out. Yes, so this piece of gear I was reviewing, you'll see in the mailbag on the 22nd is when you'll see it. But it's basically some modules which you can plug into your computer, and it allows you to do sniffing of various communication protocols. So it could be I2C, SPI, UARTs, IS485, Ethernet. Hey Christian. And things like that. And that's not only what it's limited to, you can do quite a bit. So that's just the modules you can get. The standard little USB to UART adapters, like for doing programming and like Arduinos, things like that, those work with it as well. You can just tell it it's a serial input and it'll also use that. So and the software works on Mac, which is what I'm really impressed by. Hey Dave. So yeah, I recorded that yesterday. It's pretty good. I was quite happy with that. So I've actually got a quite nice setup between bits and pieces I've got now. So I've got the I did some testing on, what did I do? Testing on UARTs and SPI. No, sorry, I2C. The other one. Hey Rob. So have you guys heard of IO Ninja? That's who the company is. Well, I think IO Ninja is more of an equipment, a brand. The company's Tibo Technology. You know, if you heard of that? Because that's who it came from. If you do a search for IO Ninja, you'll see it. But I've actually been given a discount code and all sorts of stuff, so that'd be good when it does actually come out. You guys get a discount if you actually want to buy one. You told her 5 minutes for a notification arrives. We got here 20 minutes early. She did pretty well then. So, I was worried I was going to be 20 minutes late. Luckily I wasn't. That was alright. So we've got some gear to work on today. We've got a few choices we can do. I was trying to say options. Mix the two up. So there's a few things we can look at there. Do we know the values of I and C, or must one calculate the derivatives? This is way too complicated for me. It's too early now. No, it's too early for that, Christian. Come on. Here we go. How's it going? Put the soldering iron down. Good on you. You could probably just carry on working and just listen to me waffling in the background, because I'm going to be waffling for a little while until we actually start doing anything. I'm still trying to wake up myself. Worst shenanigans were today. Yeah. Was it L and C? Or, oh, no, it must be an I. It must be capital I. Yeah. Oh man. Yeah. Anyway, so we got we got a Keithley we can work on, or well, there's a few things we can work on. Yeah, Keithley and competence tester. Yeah, maybe some other stuff. I don't know. Who knows? We'll play it by ear. Maybe, I don't know. Figure something out. You got one 30 minutes prior, really? Oh, okay. Didn't know I did that. Oh, interesting. Was that an alarm you set yourself, maybe? I don't know. I was actually thinking yesterday, shall I stream or should I write some code? Because I'm supposed to be working on a website for someone. And they've been waiting nearly a year. 10 months for me to finish it. Been a bit bad. Yeah, I did use the STB3 actually. I did use it, Rob. I used that for the I2C. For the UART, I was actually using a different device, which is something I actually want to install in the bus. I was trying to probe it to see what its serial protocols are like. And I used the UART version of the software and the hardware to probe that. Then I used the, because it's like 3 modules. Been playing the Yaesu 707. Yeah, ham radios. I've done a little bit of work on ham radio stuff in the past, but they tend to have a lot going on inside them. And mind you, the documentation is really good, so that helps a lot. A push notification. Yeah. Right. Yes, I was supposed to be writing a website for someone. I've done maybe a quarter of it. It's got a site is there and it does some stuff, but it's not finished yet and it's got a lot more to do yet. So I've got to do some quite complicated things on it. And I haven't actually done it. I haven't touched it in about a month now, actually. Nearly a month is the last time I touched it. So 3 weeks ago? Yeah, so I need to do some more on it really. Oh dear, that's a terrible joke. You need better jokes than that. Man, come on. Yes. So I'm sort of torn between doing YouTube videos, review stuff. Mind you, the review video is basically done. I think I've basically finished recording a review video for that equipment now. I'll show you in a minute actually. I'll show you. So you've got a bit of an idea what I'm talking about. Or you can look at the IO Ninja website, pull up in a browser and a separate window, and you can have a look at it. Um, it's quite comprehensive. No, yeah. So I was sort of torn between doing YouTube stuff and tinkering around here and fixing bits and pieces, and I've been able to work on the motorhome, done some work on that, got to do some work. Oh, my lawnmower died again. So I've given up on it. I was like, nah, this is it. I've had enough of fixing this thing. I've bought another one, waiting for it to arrive. Try it on the Cover 29. I haven't got any radios here to work. Well, that's not true. I do have radios here to work on, but none of those modern type ones with the serial communications. I've done the so LX has gone. That 29 LX that was weeks ago, and I did that one. Just takes a while for the videos to filter through sometimes. But yeah, that's something I could have tried it on if I'd actually had the equipment at the same time. I would have actually used it for that. Would have been quite good. But didn't go there in the end. Yeah, so I've got these things I'm supposed to be doing, and it's a matter of trying to find the time to do the right things and the right times and prioritising. But this website has been sitting there for a while. It's been the people have been very, very patient with me for very understanding that I'm very busy. So I think it's grateful to get it done, to be honest. Because what they want is very, very custom. It's not like a generic website. Chuck it up, do some page editing, add some links in, add in a couple of forms, and you're done. This is very, very customized. So it's it's a lot of special work. So everything is hand coded by me. I have to write all the code myself. So there's no templates. Ah, dear. So yeah, that's something I need to get back to. I mean, here is, I suppose I'll show you a bit. Here's part of my list. Things I need to do. Some of it's done. Here's some more of it. Here's a bit more. So yeah, that's my notes of things I need to work on. And that's just the stuff I know about now. The stuff I obviously will work out later on. As I go through it, I realise I've missed something, or not allowed for a certain circumstance, something like that. I like the new I2C Skippy compliance test feature. Okay. I might have to find out more about that. What was that thing I looked at before? There was something else on there. I can't remember what it was now. That was new. Can't remember what it was. Not had a FT102 on the bench. To new valve stuff, yeah. I don't tend to do valve stuff. I mean, I've done a couple of bits of valve stuff, but not radios. No worries about Hamas. That's fine. My English isn't great either. Just ask some of my commenters. Because I speak too quickly and not necessarily clear enunciation. Must have my name. Sorry. Yeah. Anyway. Right, so I'm thinking now. Yeah, I think we'll work on the Keithley today. That's what I'm planning. I was going to do a poll, thinking, no, I think I'll just work on the Keithley. Found because of the HR2510. Oh, yeah, okay. Yeah, it's just because of the way it's sitting on their books there. It's not actually popped up square. It's only got 1 foot on the book, so it makes it sit crooked. It's just a mess with everyone's OCD. Everyone at OCD will notice it. Well, the PA is getting nowhere near power output and it's dropping. Sounds like a capacitance or inductance issue. It's filtering it out. Probably find it's not getting the power because it's being dumped through a capacitor to ground. Offhand guess. Could be completely wrong. Or it could just be the power amplifier is actually dying and the transistors are failing. Polar's democratic, it is. But who says I want to be democratic today? No, because I haven't got much stuff here, and I'm actually running out of gear to actually. I need to buy some more stuff. I've got 3 things behind me I can work on. Yeah, 3 things. Well, one of them is very, very complicated, involved, and I really not sure I've got my headspace for it. That's why I've been sitting there for 2 years, maybe 3 years. So that's the Valhalla, whatever the hell it is, AC voltage calibrator, which went wacky. I've told you guys about it before. No spectrum analyzer, David. We've done that one. We've covered it. I went and got it and we did it. You should be satisfied. Capacitors. Loads and loads of capacitors. Hey Ray. If I do that one, can I zoom in? This is a capacitor sitting right there in a box. Okay, the ones I pulled out. And if I go slightly further out, you can see a bag of capacitors. It's fixed something, it's what we're here for, yes indeed. Hey Harold, how's it going? I've got more capacity than you think. Yeah, I've got quite a few. And yet never still quite enough. Never enough. I don't know how that works. I just keep buying them and I still don't have enough. Or the right one, or... Okay. Well, the Keithley is something I haven't even powered up yet. I haven't looked at it all. I showed it in a mailbag. Was it a 181? It's a nanovolt meter. And I showed it in a mailbag. That was it. That's what I've done so far. And I haven't even tried to power it up myself yet. I don't have a clue. We have to take it apart, have a look at it, make sure that it's okay. Do a voltage change on it. Forgot to change the voltages. And then we can power it up and see if it actually works. And if it's got any issues. We've always got more capacity capacitors. Yes, indeed. That's right, Harold. I've got... yeah, I've got 3 more sets of part drawers up there on my shelf which are empty, so I've got room for some more capacitors yet. Even DigiKid doesn't have it all. Yes, I know. There's been times I had to wait for capacitors. I had to wait for them to get them in stock so I could get them. Yeah, it's happened. Yeah. Kevin, so to answer your question, the screen is very easy. It's actually a really high resolution screen. So although it's a quite small screen, I think it's 7-inch, wasn't it? And there's a lot of information on it, like you said. It's high resolution. It's I mean, part of it is familiarity with what you're looking for as well. Why is it stinging for some reason? Yeah, so it's familiarity as well. So because I use Siglent scopes anyway, Siglent equipment, I'm used to looking at the screen, so I know where things would be. Once you've used one for a little while, then you get used to it anyway. It won't take you long. You're like, literally a couple of hours. You get to know where things are on the screen, where they're supposed to be, how to use it, and where things are laid out in the interface. It's not that bad, but although it's a small screen, it's high resolution, so it's actually a nice, easy screen to look at. I mean, I've done reviews with like some older Unity scopes and some other. I can't remember what the brands now. I've done reviews on other scopes as well, the brands. some of the, like the lower cost ones, and the screens are quite hard to look at because they're not high quality screens. They're low resolution, and so they're quite blocky, and text isn't necessarily easy to read. So having a nice high quality screen and high resolution screen, even though it's a smaller size, makes it really easy to read. It's just crisp. It's a nice crisp screen to read. Same with regular scopes. Shock to the system, but you get used to it. Yeah, exactly. You just get used to seeing it. You know, once you've studied the screen a little bit and actually looked around for where things are, you know, obviously it'll take a little while, but you get used to it. Did I have little caps to my parts bins? Yes. Well, almost all of them. Some of the ones that that Ian sent me before are not ones I'd normally use, so I put them somewhere else. They're in a box still, but I put them out in the other room because the ones which are a bit rarer or less likely to be used, I did sort them, sat there, sorted them all out, pulled out the ones which I'm likely to use, and put them in my parts drawer. So yeah. But the Siglent 800 series scope, if you're looking at getting one of those, I think if you get the 70 megahertz one, that's probably the way to go if you don't mind hacking it. Just saying. If you get the cheaper one, you can then improve it if you're not worried about that kind of thing. Because it can definitely do 100 megahertz. I think you can do 200 as well. I think there wasn't really much of a trade-off. I think it could do it okay. My understanding, I haven't actually followed it thoroughly after I did the review. Actually, once I did the review, I stopped looking. I've had too many other things to worry about. But yeah. Oh, I've got an email. I wonder who that's from. Oh, it's from Rob. I'll have to look at that. Okay. I'll check that later on. Anyway, yeah, so we'll look at the Keithley, which says nanovoltmeter. We'll see what the story is with that. It may be perfectly fine. It may just work. Or it may need a bit of refurbishment. And based on the age, it's likely to need some capacitors. Actually, I noticed Curious Mark started using my term, capacitor. He started using that term. You noticed that in the video last time. He started calling capacitors as well. Must have watched one of my videos. I think actually I commented on one of his about capacitors actually, and he's adopted it. It's pretty cool. Anyway, yeah, so we'll see what happens with the Keithley. I mean, it might be a big rabbit hole of things which don't work properly, or some glitches, or something like that. Actually, I need a source to run on that, don't I? If I need something. I need something which can generate a very low voltage. What happened to my bench? It's turned to a load of drawers. I've got drawers, if you will. I haven't got enough drawers actually. I'll probably need to get some more set up. I actually don't have enough shelving. I've got shelving on this wall here, and it's full of bins, little storage bins. Which you probably have seen me get out from time to time, and they're all full basically. I think I need to put some more shelves up. You know, the stuff I get in mailbag has to go somewhere. It goes into these bins, and yeah, I think I need to reorganise that part a little bit. That tower of drawers in the corner. You kind of see that one over there. Yeah, it goes up pretty high. Look at me reach the top. It's all right. That's capacitors. It's not all capacitors. It's film caps, X class, Y class, like polypropylene and stuff like that as well as in there, and some modules like things like SD card modules and things like that for working with Arduino, and ICs, transistors, voltage regulators, buck converters, boost converters. That sort of stuff's all over there. But that's just one set. I mean, I've got drawers there. But I need to organise some more shelving, I think. Might mean I have to take my Simpsons poster down. Got a Simpsons poster up there, which is, I don't know, what's that? What size is that thing? A0? A1? A3? A2? I think it's A1. Anyway, it's pretty big. Trying to make a high voltage little boost converter, makes 131 volts and 5 volts. That's quite a step up. Can I ask me about drawers? Yes, well, you know. My left? Oh, you mean those drawers? Hold on. You mean like that set of drawers there? That is, well, there, that's pretty high. That's 2, 4, 6, 8. There's 10 drawers in that stack, and I've got maybe 8 more like this, and they're all full of test gear. So in my other lab, which is basically like a storeroom really, I rarely work in there at all. It's for doing radio stuff really, and I need to go out there. I've got some radios sitting there, we're sitting there for ages. I need to sit down and work on. Buffering? Oh. And any test gear which will fit inside those drawers is in those drawers. So those drawers are pretty full, and then I've got piles of stuff as well. Well, it's not just the voltage, it's also the current. As long as you're below 20 milliamps or so, you should be fine. Right. Area of A0 is 1 meter square. This is rectangular. It's probably a meter across. It is going to be a meter across. Yeah, anyway. ELP driver. Electroluminescent displays. Is that what you're thinking of? They're really too simple. It's just a switcher with a transformer and then some smoothing after it, maybe filtering. Well, electroluminescence obviously AC, like DC, but they're a bit simpler. But there's no real difficulty converting it back to DC. So you could use a transformer, or you could use a switching system, like boost converter. Transformer's the easy way of doing it, stepping it up. QF 192. 192. No. I haven't worked on a 192. I'm not sure what that one is. I've done 228. Actually, I need to look now. I've got a list. Hold on. Let me look. Keithley. 225. Yeah, 225, 260. I've got a 228 as well. What was that one? Why is it not showing up in the list? No, I've got a 228. Yeah, not 192 anyway. Haven't worked on one of those. Hey Peter, how's it going? No worries, Rob. What current, what voltage? Well, the voltage is what breaks through your skin, right? So your skin is resistant to the voltage. It's the current that does the damage. So, like, if you think about an RCD or GFCI, it was the equivalent, I think, European one. I think they're like 30 milliamps threshold, because that is like the threshold where you start to feel it and start to cause problems. Hey Sven. A multi-skill Bill, how's it going? So the voltage what breaks your skin. So if you've got wet skin, for example, or oily or something like that, the voltage threshold is much lower. It could only be like 60 volts, 50 volts, maybe even less. But it's the current which is the real. You can have a high voltage and almost no current. It'd be fine. Wouldn't really do much. But I'd sort of say 30 milliamps is like the point where you want to be careful. Yeah, joules. Yeah. You're given a 192 today. Now I need to look up what one is, actually. Now I need to go and have a look. Look what you've done. Then I'll go look and go, oh yeah, that's pretty cool. I want one of those. That's usually what happens. Oh, right, okay. Yeah, I have seen those. There's not enough digits for me. That's the problem. It's not enough digits for me. They look alright. I mean, I think who have I seen using one? Can't think of who it is I've seen. I've seen videos of someone using these things. This particular unit. Was it Tony Orbis? Maybe. Not sure. Yeah. Anyway, still it's a Keithley. You know, it's going to be quality. Even if it is old, it's still going to be a quality unit. So well worth keeping it. If it's not too bad, you know, just needs a bit of a touch up and maybe recapping, that kind of thing. Great. It's probably a spreadsheet in line with animal paw resistance. There probably is. There's probably some nerd sat down one day and measured with an oscilloscope and probes and measured his cat's feet, his dog's feet. That's right. See, Ian's even starting to quote numbers now. Who's the nerd? Okay, all of us probably, but you know. No, I'm a bit of a nerd. Yeah. Anyway, we should sit down and do something instead of sitting here waffling forever. Isn't as good as it is to have a chat. ChatGTP, you cheated, Ian. Ian cheated. See, the problem is with using ChatGTP is what if it's wrong? And then that then becomes gospel because everyone keeps quoting ChatGTP. So then it becomes a self-fulfilling prophecy because ChatGTP could be wrong. Someone will mention it as being fact. Then ChatGTP reimports that as fact and becomes gospel. And therefore, you've got this circular reference going on, potentially. There's the danger of ChatGTP there, isn't it? That's the danger of it. Come out with that AI, you can, yeah, you can, definitely. Just get some oscilloscope probes and jam into your palm of your hand. That'll tell you straight away what your resistance is. It might hurt slightly, but you know. Anyway. Yes, that's the thing with ChatGPT. I mean, because it just scrapes the internet and other sources for data, and it uses that data to fill in the gaps, all right, and generate its information. So if it's got one source which is wrong, it'll assimilate that, then everyone else will assimilate that information, and then you end up with it being completely wrong, and everyone is wrong because they become reliant on a technology which, although it's pretty impressive, it's questionable. Yeah, testing on batteries is on you, right? So you know that's a early life lesson. That one. Had to catch a cat first. Less than 10 microamps. Yeah, okay. That'd be for high voltage though, wouldn't it? Used it to sum a list of 50 numbers and he got it wrong. There you go. How many people are relying on it, are they? And how many people are using the ChatGPT information all the time as, oh, this is it. It's a computer, so it must be right. No, it's only as good as the information that goes into it. You probably come back scarred. Yeah. You put it, slashes down your face. And programming is great. Yeah, I hear that, but I know people have used it for generating code. So hey, I want a for loop that does this 20 times, and whatever. So I've heard, but yeah. Anyway, let's do something else. Let's fix something. I'm gonna need some more lights. Wait for self-driving cars. Yeah, well, exactly. That's my concern. Knowing, having someone, being someone that works with electronics and fixes electronics and sees what goes wrong, relying on a computer for your safety, entirely like that. It's just, I think it's just ridiculous, really. I mean, if there's like multiple redundant systems, yeah, like you got 3 computers in parallel and it compares the results. If one of them's in error, it ignores that one. Yeah, it wouldn't be so bad. But I don't think they do that. Just putting up the chat on my screen here. Self-driving semi-trucks, yeah, that's even worse. Because then it kills everybody else around them as well as the driver. No caps. Yeah, I think there's capacitors. Right, I need to do video on this as well. Let's adjust this camera. I bumped it earlier on, so now it's all wonky. Oh, so the program is crap. Yeah, well, it's not as good as the software, isn't it? Let's say allow for absolutely every situation and have the intelligence to recognise the difference between a line marking and the fact there's no line markings and it's a ditch, which happens to be white painted. I don't know. A sign, a billboard sign on the side of the road or something. Anyway, wobble going on there. So I need to record video on this thing. Let's get the other camera going too. I'm trying to decide which view to use, or I should use top view or if I use the other camera view. It's a bit dusty, it's been sitting there for a while. Oh no, it's just dirt. Old stickers. Maybe dust has stuck to old stickers, I don't know. Okay, let's change to the other camera. Here we go. I still need to do a video on this thing. I think I showed it to you guys before, didn't I? It's a Mega wind-up one. Got it for $15 from a charity shop. Well, my wife found it. She's in there browsing around. She saw it there and thought I might like it. Let's do a video on that yet. Two little ducks. They're from Big Tree Tech. They come with things you buy from them. It's just trinkets lying around just to make the background look a bit more interesting. Before the other camera view. Okay, you have to have a vote about camera view, eh? Okay, we'll do back to that one. You prefer that view, do you? That straight down view. You want that one? Shot loads of plumbers, yeah, hook up to the pipes and give it a whine. Yeah. Okay. Right, I need to focus. Focus. Get my head into it. Repair. Focus. Okay. So you guys can see top view. I need to remember that you guys have got a different view from what I'm looking at right now. Right, so what I can see on my monitor over here is not what you guys are seeing, because obviously you've got top view up there. So you have to try and remember that. If I'm talking about something that's on the screen, yell at me in the chat, and if I'm lucky, I might see it. Because I might be talking about something that's on display and you can't see it from there. Although I could do a different view. It's just we could do this one, maybe. Bit messy. I thought that was full screen view. Hold on. That's on my Stream Deck. I don't think I've got it programmed into the Stream Deck. The other view I want. Hold on. And I've got that one. Dunno. Why is it I still don't really have enough configured camera views? This is a bit. Film camera view is best, so you want the front view? Okay, we'll just go with that. We'll go with that. Then I can see what's going on. I can see what you guys can see. Alright. Yeah, well, I've got lots of cameras. I think really you kind of want like this camera here with the top view at the same time. And I could set that up. Oh, we could just go with this one. This is what's going to end up being recorded into a proper video. So it should be the better view, really. Right. There we go, fall off your chair. Did you fall off your chair then when I zoomed in? Right. Take a picture of that. Do I push the button? So today we're going to look at this thing here, which is a Keithley 181 nanovolt meter. I haven't powered this up yet. I purchased it a couple of months ago. It's been sitting around for a while now, and haven't powered it. Got no idea if it works properly. We'll find out. It actually comes with the actual connection on the front, which is nice because these are a bit harder to find. Special connector because it's all nanovolt rated, you know, so low leakage, and it's got bananas on the end of it. And also a clip lead, which would be like the probably ground, I guess. I don't know. So look, is this actually done? I haven't looked at this bit yet. So I've winded. Okay, so it's paired it off. So they got clip leads and bananas on the same connections. Right, these look like nice clip leads. They actually look like they're gold plated, maybe. Maybe. Oh, they're brass. I'm not quite sure. That could be copper actually. Just copper. Yeah, just copper clip leads. But they look alright. Whether it's someone's made up or what, I'm not sure. But no, it's about a metre long, something like that. So, we've got a lead to use with it, which is really important. This currently is not changed voltage, I don't think. Let's have a look on the back. Yeah, so this is currently set. Well, it's marked as being that voltage. Where did I get this thing from? It's marked as 210 to 250. I'm just trying to remember where I actually built this thing from. Whether it actually is there or not. We'll have to open it up and have a look. I want to make sure before I power it in case I blow the back end of it. So obviously it's got GPIB and it's got some analog outputs on the back here as well. So if you want to hook this up to like a digital meter, which has got high resolution maybe, I don't know, or some logging system or something like that, you potentially do that. Interesting, it's got this RFI shielding sticker on here. Interesting. Well, if that as an option or upgrade or something. So yeah, it has 6.5 digits on it, but I don't think it actually is 6.5 digits. I think it's only like 5.5 because the first one's potentially enunciator. And there's this press buttons, the monetary buttons here. Obviously a big clunking power switch, which is always nice, and obviously the inputs here on banana jacks. So we'll have to have a look at this and see if it even goes. Hopefully it does. Great news for low noise measurement. Well, if you've got this little flying leads hanging off, I'm not quite sure if that's going to be helping that, is it? It's probably not the best idea to have leads hanging off them, because that's going to potentially be picking up noise, isn't it? Be acting like an antenna. Anyway, that's what came with it. Right, let's get the cover off and have a look inside, see what we're dealing with. So I've got no idea, I haven't researched it, I haven't read the manual. In fact, I'm not even sure I've got the manual for it. I may have downloaded it. I may have done, if there was one. Don't actually remember. Is that enough to get it off? It is. So it's got shielded casing, that's nice. And there's the inside. Lots of film caps. Just adjustments along the top edge of here. That's nice and easy to access. Shielded can. Calibrated by 1065. And set it by 1300. Okay. We've got some dates now. C84, some nice chips. 84 on those ones as well, so I'm guessing this is 1984. And there is indeed a selector switch down there for voltage. Let's just change the view so you can see it. So yeah, there's a switch down there for voltage section. It is indeed on 230, so great. I don't have to change anything there, so it's safe to plug in. That's brilliant. $19.95 calibrated signal. Where did you see that? Don't know. I don't know where you saw that. You also seen something I didn't see. Clean, yes, it is clean. Oh, it's safe to plug in. Oh, that's interesting little header setup. Show you that. I'm trying to get the lights on it and get it focused and all that sort of stuff. A little setup in there, so I've seen this done. So this basically it's a long leaded socket which is all offset. So it's got the dip switch on the back. I've never seen that done before. That's interesting. The blue round sticker on the back. Oh yes, so it is. The third month 95. Well done. It's so obvious, it's not obvious. So yeah, that's what's being referenced as that. Yeah. I didn't see that. Okay. So the capacitors look fine, I think. Actually, no. This one's knackered. That cap's gone. Alright. Excellent, we do actually have something to fix. So let's record some video on this. So, just a quick visual inspection around it. I've had a quick look. Nothing obviously bad, apart from one capacitor. This one here, it's very wobbly, like it's extruded at the bottom, and the top is very slightly bulged. That is bulged. So this cap is gone. Now you also got these other smaller ones down here. They're dead flat still. And the ones over here, there's a couple of small ones down there too. They're looking alright. Visually look okay. I'm not seeing any leakage on the board, which is a good sign. But that big cap there is definitely gone. That's bulging. It just, nah, that's not right. In fact, it's not sitting flush on the board. Mind you, these other ones aren't sitting flush on the board either. Maybe this one is extruding, or it's just not put in properly. I'm not sure. But I'm tempted to just replace them all. There's not many caps in there to replace. Let's take the shield off and have a look underneath the shield. See what's going on there. Interesting screws. They don't seem to screw in very far. I'm not sure if it's falling apart or if there's something else going on. I think it's falling apart. Cover off, yeah, okay. There's a sandwiched cover, and the bottom cover fell off as I was unscrewing those. There's a panel underneath this PCB as well, which is now floating around. So that's what's under there. Always pays to have a look. We've got a voltage reference over here, I think. LM399. Yeah, LM399H. Voltage reference. No cover around it, I'm surprised by that, but then it is inside of basically a sealed enclosure. There shouldn't really be any airflow unless there's no fans and no vents, so it should be okay really anyway. Whole enclosure will be probably alright. No, it's worth covering it though. Is it worth it? I don't know. We've got this poly cap over here, film cap, some precision resistors, obviously a few adjustments and stuff, but that's looking alright. It actually looks like this ball can lift out. I'm not going to do that, although I probably should look underneath it and see what's going on there. Okay, let's take the board out and have a look. Good luck putting those back in again. Yeah. I think I might need to put my gloves on too when I'm handling this board. Got the relays, hopefully they're okay. Could do without any dirty contacts with relays. Two screws and I think it lifts out. Right, let's put some gloves on. Seeing it's got precision stuff on its board. No high-end reefers. Oh, well, I haven't looked that closely for reefers actually. Well, it does have a filter, so the filter could blow up. Always that hope, isn't there? No dust. Yeah, that's because it's sealed basically. There's no vents or anything on it, so it's completely sealed enclosure. Right, now we've got a couple of connectors over here, which are the input connectors. Let's video this. So over here we've got some connectors over here which go to this board, which go through this inductor. Basically it's a ferrite there with it round, going to the input jacks there. So I'll put my gloves on because I want to take this board out and see what's underneath it. And this is covered in position stuff. You got these Teflon standoffs here, these isolators on the board. So it's all precision. You don't want to mess with this and get it dirty. So That's what I've got the gloves on. So I'm going to pull these terminals off here, and then, maybe I might actually leave them on, and I'll see if I can lift the board out and just see how that goes. I don't know if I have to take that one out as well. I think I might take that screw there off as well, maybe. Looks like it is a standoff. So I've already taken 2 screws out. But it's got these little headers down here which push in. So what I'll do is I'll lift the board off. I'll put some deoxit on these to clean these up a little bit, and then I'll reseat it as well. Reseating the connectors is always a good thing to do, because they do gradually tarnish. Take this one out as well. Pretty sure it's meant to come out. Yep, that wants to lift up now. Okay. These connectors are very tight on there. Yeah, these caps here, this one here, that's one which is bulging, so it's probably just been getting too hot. I mean, I doubt the transformers will be getting hot really, I doubt they'll get that hot, but that big heatsink there is likely to get hot. Why? I said this on, I think it's Curious Mark's channel when he's talking about capacitors. I don't understand why people keep on designing these things. Actually, I'll comment this on video. Let's just adjust my view a little bit. So before I take this board out, I'm just about there. I've just got to lift the thing off basically. These capacitors, right, I really hate this design where people will put all the power stuff together, which is fine, you know, in a way. You think, okay, you're going to put your smoothing circuitry and your filtering right by your regulator circuitry, which is sensible. But when you're sticking capacitors right next to a heatsink, that's not good, because these things get hot. It ages the capacitors much more rapidly. And instead of getting, 30, 40 years out of a cap, you might only get 5 or 10, maybe. I don't know. Depends on the caps. But, having a rapidly aged cap, and this one here is definitely gone bad, and that's because it's next to this massive heatsink here. Alright? So the heat from this is radiating the capacitor and aging it and making it dry out quicker. The hotter they are, the shorter the lifespan. So putting capacitors next to heatsinks is one of my pet peeves, and it's so commonly done. If you ever design anything, don't put your big bulk caps next to heat sinks. Move them away, even if you're only 20 mil away from it. Just a bit further. Just get them as far away from it as you can, because this is not good. This is from a Keithley. Yeah, right. Right, let's try and lift this board out. I've got all the screws out now. Here we go. So I fold it over. You can see all the Teflon's really clearly here. Let's try and balance it some way so it's not going to get damaged. Like that, that'll do. It's got this shield here which can come off the bottom. That's those little screws went into it. Only barely went in, literally. Only a couple of threads in. Those bolts are a little bit short. And let's just do this. That's what's underneath. So that stand off there, which I have to be careful of. Got some chips. You've got an EEPROM over here. 181B9.1. I wonder if I should pull that and back that up. Probably be an idea to, eh? Might go and see if it's available online first in case I'm wasting my time. Oh yeah, definitely is a high quality caps. There will be. Mind you, they're called the Ritchie brand caps. Never heard of them. Taiwanese caps. Yeah. In Taiwan, stuff's actually not been too bad, is it? Used to be reasonable quality actually, but. Yeah, I need to find out if this or maybe one of you guys want to go and look for KO44BB or some of those other sites and see if the 181 version 9.1 EEPROM is available online or not. If it's not, I'll pull this one out. Yeah. I don't want to remove it unless I need to. I just don't like to disturb, potentially damaging the circuit board or traces, or cracking something. It's always a risk when you take things out. So I like to try and avoid that. So, can you want to go and have a look and see if that EEPROM's available online? KO44BB is one of the ones I usually go to. Maybe XDevs has got it. I don't know. Maybe it has. Sort of thing you'd have, eh? XDevs. Might have one of these. Okay, so that's that. I'll do want to clean those up. Obviously, getting this back on again could be interesting. I can get to one of the screws. If that's back in place. 2 screws. No, I can't get to there's one screw I can't get to if I have that cover in place. Hi Ken, how's it going? Right. So we definitely need to do some repair work on this, but I think I can probably, hopefully, just take the bottom cover off and that'll get to the bottom of the PCB. Maybe, I don't know. I'm not quite sure how it's set up. Whether I can get to the bottom of a PCB or not, I'm not sure. Obviously I need to get that cap out, well, all these caps out and replace them. The best to do it now, I mean they're pretty old, they're 40 years old, so it's time to replace them. Anyone found that EEPROM? No? I'll go and look myself then. Okay. 181, Keithley 181, let's go and have a look. Let's see if I can find it anywhere. And you can sit there looking at the other stuff, I suppose. Carry on looking at the Keithley, admiring it. Keithley. Why isn't there a Keithley folder? Seriously. I'm looking at ROM images and drivers. Is there a Keithley in here? Keithley 196 and Keithley 224. Okay, so KO44BB doesn't have them. Oh, you found it on KO44BB. Where did you find that one? Because it's not the same one I'm finding, but okay. Maybe it's in a different folder somewhere. Tektronix is a good copy of the service manual. I may have already grabbed it. It's quite likely I did. Usually when I buy a piece of gear, I'll make sure I can get a manual for it at the same time. Usually. It may even be a hard copy, I'll buy that at the same time. Okay, let's carry 44BB. Now, Barmer. Look at Barmer as well. See if they've got it. Barmer don't have it. Okay. Well, let's look at XDevs. I need to log in the other way. Because it's got a login on there now. I know you can't see what I'm doing, but it's not that exciting. Docs. You did give me a login for this. Right. Keithley. XDevs 181. Hey, XDevs has got 181. And it's got various stocks for it there. Firmware. That's on XDevs. 106B9. Yeah, it's the same one. That's the same firmware file you found there. So that's on XDevs as well. I'm not quite sure what the 106B9 references. I mean, obviously this says 9.1. Does this mean this is a newer version? Yeah, I've carefully placed it to not damage anything, hopefully. It's just resting there gently. As gently as the borders. But I did try and carefully place it so I wouldn't be putting stress on things. Of course I could have unplugged the wires, but I'm wondering now if this B9 actually means that I need to... What does Pro 106 mean? What's Pro 106? What's the relevance of that, I wonder? But anyway, XDevs has got the documentation and stuff there, so that's good. He often does. I reckon this might be a newer version. I was wondering what the Pro 106 is reference to. In case there's like a model number somewhere, a secondary model number. Trying to see if there's anything which looks like it could be referencing that. Nothing on the boards. Yeah, I don't know. I think I might need to pull this EEPROM out. Sit there nicely again. It was sitting nicely before. There you go. I think I need to pull this EEPROM out and save it. Which means getting the programmer out. Hold on. Which program am I using for this? Oh, I need to use the... Alright. I need to use my wife's PC for this. Some pet peeves is not even a programmer for bloody Mac. Let me just find it. I've got a box of programmers. I do have the Bactronics one here, which used to work. Yeah, I'll change camera views. This one. So I've got this Bactronics one here. Alright. It's the BX32. I had it for years. And the software for Mac was never very good. It was really glitchy and crashed a lot. Works on PC. But I've got that. I've got the GQ 4x4. And I've got XGCU. Yeah, I've got several programmers in here. But none of them want to work on Mac. I think there is one which is like a command line option. Done a go there. So what I do also have, which I've been using more recently, got some limitations, is this one. But this works on a PC only. So I wish I had a Mac version for this. Obviously I could use the other ones on the PC, but I've got the software on my wife's PC, which means I don't have to go fishing for another one. Mac life, yes indeed. Let me get this thing out. So I'll quickly jump on my wife's PC and use it on there, because that's what I've got it set up for. It is set up on there. It's not the sort of thing I use very often, so it's just the way that is. So I've got to get the cables out and everything. Power supply brick. You have a cable. It has the wrong kind of power plug. That's okay. That's why you have def adapters. So power cable, programmer, and now your USB cable. Right. So yeah, I'll pull the EEPROM out and I'll save that, and that'll be available online then after that. Now the shirt, you can buy it too. These are available. You can buy it yourself if you love it. So it's on my. If you open up the description there's links down to my Teespring store. You can get it from there. In fact, I think I could even get on my thingy. Hold on. I've got it set up here as a shopping link. Let me check. Where's my mouse? Here's my mouse. Mouse. There you go. I'll pin that one. There you go. I'll just pin it to the chat so you can get it in it yourself if you like. Right. Obviously I can't show you what I'm doing here because it's secret. Plug this in. Give me a second, people. I've just got to sort this out. Ottoman. Now I had issues with this last time trying to get it to work because I used the wrong thing. Just plug the power in. Obviously I'm not going to come back and pull the EEPROM out yet. Looking for the programmer, right. Come on, find the programmer. I think that's probably the wrong program. There's two different versions on here. As you can see, I don't do EEPROMs very often. Okay. We have the programmer connection. I need to change the device it's going to be usable. I think it's a 2732A. That's what's mentioned on the other one at least. I imagine it's the same device. Leave my chip puller. Which one's this? Flashes to the wife. Sound of writing you like? Okay. Come on, here you go. There we go. Chip is pulled. Really nice these ones because you can push it, because what it does, it pushes against the socket, and so you're not actually pulling on the board, it's pushing against the socket when you pull the chip out, so it's less stress on the board, so I quite like it for that. Now pin 1 was up there, yeah, of course matches the socket, that's all fine. Now I think it's a 2732, I better check that before I shove it in there. I'm just killing it. TMS 2732A JL. TMS, okay. It's programmed, the programming. Select device. A TMS. Okay, device is loaded. Read it. Reading is done. Apparently reading is done. Where's the list? I want to see the trying to see where the hex is. I can't see the hex. Where's the buffer? Oh, there we go. Right, here's the buffer. Okay. I've only used this thing a couple of times. Right, well, it's definitely got a whole bunch of data in there. Try and see if I can see anything which looks legible, makes sense. Looking for like text, basically. Not seeing anything like textual. Which I would have hoped to have seen. Because that's our way of confirming that it's actually loaded correctly, if you can see some actual raw text in there which you can read. Oh, I can see milliamp, there we go. I can see MA. That looks, it could just be coincidence, but okay, well I'll assume that's okay. Save it. Is it B9.1? Okay, file is saved. put it back away again afterwards. Let's put this thing back in. Right, going to refit this board. Let's get the camera back on again so you can see what I'm doing. Get the camera going again so you can see what I'm doing. I'll say it again. Right. Right, chips back in. Catch up the chat. Yeah, the wife's out there somewhere, she's doing stuff. She's working in her room, she's got a room set up as well for Poppy. Have a steak 301. Yeah, the XGCU one, whatever it is, XGCU. It's not a bad program, but I think it can't do some of the high voltages. Can't do like 25 volt, I think. Something like that. Steak, been around for a long time. Program still make a good price on eBay. Right, so that's that. I'm going to put this back together again. Put some deoxit on these pins so it's got a cleaner chance, at least not oxidising further. They're not gold, so I'm just going to use standard stuff, which is probably going to spray everywhere and make a mess. So I'm going to put this down because it's likely to catch what I overspray by, hopefully. Right. Start running right down the legs, you know. Doesn't need to go down that far. Putting this back on is going to be fun, but make sure those are lining up properly. They are. Come on, push down again. Maybe they're not. Come on, line up. No, it's definitely going in. This is going to be my downfall. We'll try and get these plugs back in here. Definitely kind of dropping in there. This side doesn't want to bed in. Why is this one being awkward? Come on. It kind of wants to go. Why are you being such a pain? There we go. I got it. Right. Now in our place.
subscribe right now, quick, before you forget.
That's fortuitous. Those aren't the right screws. It's these screws. Oh, come on. So the problem with the gloves, they get in the bloody way. Trying to do stuff like this. Did I put notes on Twitter that I was live? No, I didn't actually. That's a good point. I should have done that. Oh, I forgot to do that. I used to do it all the time. One of the programs I've got is like the very first program I ever bought. I've still got. And it used to run, actually it came with a 5¼ inch floppy disk. That's how old it is. I've still got the programmer, but I've just got no software for it anymore. I've still got the original software backed up. I've still got a copy of it, but obviously I can't use it or anything because it's just too old. If I had a really old computer, I could probably get it going again, but I haven't gone there. Let me just go to Twitter and mention that as soon as you reminded me. It's funny how it's called X now, but everyone still calls it Twitter. Okay, post it on Twitter. Just one of us is thinking. Now I'll try and get this bottom board back on again once I get the top panel back on, because I don't think I can get to that screw with this in place. No, I can't. So I have to put this in place first. Okay, well, this is interesting. And so this screw's only barely long enough. Yeah. Now let's try and... Yeah, this will be fun. How the hell did I design it all that? Yeah. The only way I consider do this really is to have a really long screw, which you then get lined up and then pull it up and then get 3 of them in and change that one long screw. Yeah, fun getting it back in again is definitely the right word. Let's try and get one screw in and hopefully it'll sort the rest out after. I don't think that's got it, I think that's missed. That's not got it either. Who designed this? Can I do it by sight like that and then like that? Maybe that'll work. Okay, it's one screw in. Is that enough? Do you think that'll do? You stop there? Yeah, nah. So going in, that's going in, right. Wow, that's an interesting design. Whose idea was that? Could have done this much better. I could have sandwiched it. Just had like a set of standoffs on the back of the board and sandwiched off that. Okay, right, there we go. We're all better together. Okay, back to where we were. Right, so I've refitted that now. Put the cover back on again. There's a bit of fiddly getting in there. It wasn't that bad, but you had to kind of get under one corner under here and get that one screw in, and then this screw in, and that one, and that one. So a bit of messing around, but it's back together now. So I think we can actually power it up because, well, mind you've got that capacitor to do yet. Let's take this bottom cover off, then we'll change the caps, I think, before we do anything, because otherwise we might have a problem with it. Because I think that cap there is gone. I think I'll just change that one and then we'll power it up. Assuming I can get to it to change it, of course. Oh, okay, catch that this now. Spin. I'm going to say it properly. Am I lagging, am I? Just trying to see my OBS screen there. Haven't dropped any frames, so it's not my side. It's obviously just a YouTube thing. Okay, well that's out of there. So, why is it not moving? Let's go in there. Have I got it? I think I'm going to take all these off as well. I think these ought to come off. Yep, we've got to take all those standoffs off. Okay. Do you know something annoying? I might take the cover back off again. There's one right down here too. I think I can get that one off actually. No, I can't get to that one. That's alright. There's that long screw. Hope that standoff doesn't fall right out. There's one right down there. That's awkward to get to. Let's lift that board out. Okay. Let's just adjust it for you a little bit. So I've got to try and get this bottom cover off now. That's being tricky because the board has actually got these little circular standoff things that go over it, which go through to here. There's one underneath this board here. I've got to take this board out to get to it. This one here I've taken off, which I think is okay. That's all I've got to do. That's a screw I can still get to, thankfully. Then I'll take the cover back off again. That would be annoying. But I've got a board here which looks like I've got to lift it out so I can get to the other screw, which I didn't mind lifting out anyway because I wanted to reseat connections anyway, so that's fine, lifting it out. Ah, there might be a problem after all. Let's just lay this down. So there's two of those plastic standoffs down there, those little mounts, which means there might be one under that board after all, which means I might have to take that board back out again. I hope not. There probably is one, isn't there? What's the chances? The chances are quite high that there's one underneath that board, so I have to take the board back out. It's quite likely. I guess we'll find out. I'll take those out. I'll put that board back in again. Well, I'll actually put some deoxit on it, then I'll put it back in. Trying to catch the excess spray. Right. Don't have to go either way, I only want it on the pins. Put that back in. I think there's another standoff. That side's moving. Yep, I've got to take the ball back out again. That's annoying. Damn it. Well, use a hammer and no, it's all screwed in from the top side. Let's take this back out. Easy if these screws are a bit longer. Anyway, never mind. Get that out. Take this back out again. At least it's easy to do. Just a bit annoying. Certainly could have been worse. Carefully. Put it back in again so it's protected. I'll get it back in again. Okay. Start it floating around. Okay. That seems a lot freer now. Is there more? Pretty sure there's nothing under there. Why does that still not want to come out? move in there. Feels like it's stuck to the front panel. Oh, is that a screw down here? Seriously? I think there's a screw down there, so I'm trying to see how it's attached. I don't think there's screws under the feet. There's a screw there. Trying to see what that screw actually does. I can't really get to it. Well, the sides are kind of lifting, right? But it's not. This side feels quite tight. It's lifting up a little bit, but not actually releasing. And this side here is the same deal, like lifts up a little bit, but it's not releasing. Maybe there are screws under here, but I'd be surprised. But I mean, that foot's already gone off this one. There's nothing under there. There's got these recesses here, which I think is a pin. So I don't think I can just lift it off. Nothing inside that recess. What holds this on? Come on. It's definitely on the very front edge, right? The very front part is what's holding it. I mean, have I missed another standoff? Let me just take this pull back out again. Let's have another look underneath in case I've missed something there. Oh no. Also missing something. Shouldn't be that hard to get the bottom cover off. Unless of course it's not just a cover, but actually the chassis itself. I mean, there's a standoff there. Is that standoff the problem? Are these standoffs attached to the plastic? No, because that's moving. Oh, I don't know what I'm missing here. Checking with a magnet on the feet, that's an idea. No, there's nothing around here I could see. I couldn't see anything around there. I don't want to force it. Everything else appears to be attached to PCB apart from that one screw down here, which I don't know. I can't see what that's attaching to. It might. I don't know. It's just. Let's see if I can get to that one and get that one off. Maybe it is just that one, but. Feels like more than that. If I can get to the bloody thing. I can reach it, but it doesn't fit. Let's get a different one. It wasn't even that tight.
There's all that crap on my desk.
I might have borrowed it for a little bit. Been sprung. Right, then that screw out, whatever that does. Oh, do you know what? There's one on this side as well, underneath the power switch. Underneath the power switch. Oh. Let's see if this gives us any movement. It does. Alright, so how are you supposed to get to one that's underneath the power switch though? How on earth am I supposed to get that out? Yeah, so the screw that side is definitely freeing up that side, alright? So that is now wanting to move, alright? So that's definitely what's holding it on, is that screw there. But the one underneath the power switch, how am I supposed to deal with that? Power switch is soldered to the circuit board. There's probably some really obvious way of doing this. I just don't know what that is. Let's try and see if there's a way of lifting the board out of the chassis rather than lifting the chassis off the board. Because it could be that way instead, which would make sense, but even that's not looking likely. This is a pain. Okay, Dave, thanks for dropping by. Get low. You think it slides out? Well, that's what I thought too, like the top cover did, but there's definitely a screw under here. That screw right there is holding that, right there. Well, the other one I've took off is loosened it up. And taking the front panel off is possible, maybe. It's all bolted together. That might stay in place. That would come off, but then I've got to disconnect all these connections at the top here. They'll have to come off. But I think that screw is holding the front panel onto the bottom piece. Screws on the front panel sticker? Well, possibly. But then you've got the power button right there, so I don't know. Don't feel anything. Don't want to force it. That's always a bad idea. Well, so be coffee and biscuits,
Which you can't eat.
which I can't eat.
You have to have, like, a cookie fork or something. You can't hold the biscuit whilst you're wearing gloves.
I can take the glove off. Right. Oh, come on. There must be a way of doing this. Okay, so there's this front panel PCB here. It's got two screws on the top. It's got a connector down there, right? And it looks like it's got a slot that sits in. So I should take that front panel PCB out. That will give you slightly better vision under there. That may actually be a clue to how to get it apart. So let's go with that. Or is it? Oh no, seriously? No, I take all the button tops off. That's risky. It's a risk of breaking the switches or breaking the button tops. Forget that idea. I don't want to do that. Not liking the Heathkit design so far, to say. Oh no, I've lost a screw on the floor. Oh, Fred's going. Just like Fred. All this just to try and get the thing apart to replace a cap. It's a bit ridiculous, really. Yeah, well, I think I need to actually have a snack myself now. Let's just get these gloves off, have a snack and a coffee, and then I think maybe the manual's got something in there about how to get it apart. Let's have a look at the manual whilst I'm eating a biscuit. Alright, manuals. Keithley is here somewhere. 181. Let's have a look, see if there's anything in here. Nothing obvious there. Oh, what? Looking for disassembly diagram. Sugar diagram. No, this assembly diagram. Oh, that's awesome. Unless I've gone past it, but I think there is one. This is annoying. Yeah, that's all I saw was that thing. Those little diagrams there, those illustrations. Yeah. Nothing. That's helpful. Let's look at the diagrams for power supply stuff. Where's the power supply stuff? There it is. So linear regulators at least. It's obviously why the big heat sinks are all in there. $1,500, $1,500, $1,500, 100. 6.8, so those are probably tantalums. No clues, yeah. Well, that cap needs changing because it is bulging. It has to be taken apart. I've just got to figure out how. There's a 10,000 here, so I think that's probably the one which is bulging because it's the biggest cap. So that's on the 5-volt digital rails. Okay. It's got -15, +15 ground, 5-volt analog digital common, which is the same as that one. -15, +15 digital, plus 5-volt, which have probably got a shared common over there. Yes, they do. Shared common there. Okay. Yeah, I don't really want to pair up without replacing the capacitor. I mean, it might be alright. Some digital circuitry. It's before the regulator, so the regulator is going to be buffering it. So even if it is a lot of AC ripple there, the regulator will do a reasonably good job of sorting it out. So that 5-volt regulator, which is affected by that big cap, that's fed off the plus 15-volt rail. So I've got the plus 15-volt rail coming out here, then feeds into the 5-volt regulator, and that big cap is on that 5-volt rail through this pass transistor here. So obviously then this regulator here is controlling that pass transistor with this arrangement here with the feedback as well. So it might actually be okay with a bit of ripple. I'd just like to get it powered up, but we'll do it anyway. I think let's power it up. It's in a state where it can be powered, so we'll power it up and have a look at it. Yeah, exactly. It's not shorted. Well, hopefully not shorted. It should be safe to try. It's not like it's after the regulator where it needs to be a big bulk supply for that, but I mean the regulator will smooth a lot of the AC out. They're actually quite responsive, especially as it's got a 10-volt headroom off a DC supply. Mind you, it's only using that as a reference. Oh, yeah, actually, yeah, because it's using that regulator there as a reference with a feedback from the output. I mean, the feedback should cover it, I suppose. And it depends how slow the loop is. Okay. I really want to get that thing out. If I pull hard enough, it'll pull the stud out. It's a metal threaded insert. Don't really want to do that. I still don't understand how they got the screw in the first place with the power switches above it. It's as though the ball went in afterwards. That's the only way that could have happened. Did I assemble the chassis then drop the ball into the chassis? There's screws through the board though, which is interesting. The power switch is soldered onto the circuit board. So the circuit board must have gone in after that screw was put in place, surely. So that board must lift out. But lifting that board out is going to be tricky. The transformer appears to be attached to the circuit board. Or it could be passing through the circuit board into the chassis. It's got like nuts on it with lock washers. Well, if I pull the cap from the top, it could rip traces off the circuit board or damage wires, stuff like that. It's not worth the risk of damaging it, so I'd rather not be forceful with it. I mean, there'd be a way of getting it apart. It's a matter of approaching it the right way. I'll finish the coffee and I'll get back to it. I'll look at a different approach. I'll look at see if I can get the circuit board off the chassis rather than the chassis off the casing. Because there's two aspects to that. I can't say the bloody word. Everything has to come out, you reckon? Okay. Well, that's what I'm leaning towards now, is looking to see if I can get that circuit board out of the chassis. But it looked like it is sandwiched, but anyway, let's get back to it. So, circuit board is moving in the metal frame slightly. I'm trying to see how to get this part out, because I've got the GPIB socket sticks out the back, right? So I can't just do that bit. I'll take the rear panel off. Because you've got a couple of screws for that. It's like one screw down here, which goes to this chassis rail. There's a screw here which goes to this chassis rail. That will free the back panel or the chassis rail, which means I can then potentially lift the board. It's right now sitting on that back chassis. Oh, you've gone blind again. Page 67. No, I don't see a link. It didn't show up. Didn't show up in the chat. Because you have to be an admin or a moderator to add links. Usually it show up and I could approve it, but it's not even done that. Right, let me just think about this. I'll take the back panel off. I may need to detach this. Because of the wiring going to the front panel, I may need to detach those as well. And I think that might be doable. The only thing I've got these wires on the back here which go to those posts, so I might have to disconnect those posts. I can unplug the main AC side coming in. So I might take the wires off those posts, leave those attached to the board because they're soldered onto the board down there. Unplug that, disconnect that, unplug those two wires there. Okay, that might be an approach. Let's see what we get. You know I'm going to mix all the screws up now, don't you? Oh, you're trying to email it to me. YouTube@defpom.com or .co.nz, which is what I'm tending to use these days because the .com one had issues. It's still really solidly attached. It's moving there. Okay. It's kind of a catch-22 here. It's still caught on this piece. Yeah, the thing is, it wants to lift a little bit, but I can't get it lifted enough. It's got an email. Let's have a look. Page 67, you reckon? Let's save this version of the manual. I'll open it up. Page 67, that's what I was looking for. Okay. This one here. Yeah, it's not really telling me a lot more, is it? Apart from the fact the top cover lifts off and that the bottom one doesn't. And that's the circuit diagrams again. Yeah. Didn't really tell me any more, unfortunately. But at least I got another copy of the manual. Different version of it. That would be handy at least. More complete by the looks of it. Okay. Back to this. This is kind of wanting to lift out, but it's around a GPIB connector. So it sort of wants to lift, but I can't lift it out because the GPIB connector's in the way and I can't get the bottom cover off. Get it around there, maybe I can get enough. I'm just not liking this. That does not want to move. If I can move the circuit board forward, maybe it'll work. Can I lift the circuit board forward? Let's put some more gloves on. Or touch something I shouldn't. And I've got like 20 gloves instead of just the 2 I want. Lift this out again. Although that seems to be coming with the board anyway. Let's put this somewhere safe. It'll probably slip on something anyway. That's it. So that's attached there, right? So that's lifting there. That board that side is lifting. Board that side is lifting. I'm going to have to take this off. Just take this board out and put it to one side. Okay. Let's put this there, upside down. So the board and the rear panel come out together, potentially, yeah. So that won't lift there because the power switch is in the front panel. That's lifting, but only so far. So I need to slide the front panel, slide the board forwards, so I can release it from the back panel. That's what I'm thinking. No, can't slide it that far. Now I seem to have got it wedged somehow. Right, so I can't lift the board because of this side panel here. The side rail is in the way, which means the board has to be slid forward to get it past that side rail. But it doesn't want to slide forwards. Oh. What's going on? So that front panel switch is pushing against the half front panel right now. I can't really move it any further forward, I don't think. Wow. This is such fun. That side's moving freely. The back is jammed over here somehow. Not quite sure how I've jammed it, but I seem to have done that somehow. There we go. Right, it's unjammed there. It kind of wants to lift, but it doesn't. Prediction, all the screws going back in. Yeah, all these screws are out, so that's free moving there, that's free moving there. Problem is, I kind of need to move the back panel backwards, but I can't because the casing's in the way. And I need to lift up more to get the back panel off, but I can't because the PCB's in the way, and I can't move the PCB because the side channel's in the way. Let's pull this off as well. Come on, there we go, get that out of the way. It's just sort of almost goes, but not quite. I can't lift it up high enough because of this side panel. So it does kind of need to go forwards, but I can't move it forwards. Right now that's as far forward as I can go. Yeah, that's as far as I can go. It might be a big enough gap now. I'll get to stay forwards. Hey, it's looking promising. I'm past the awkward bit. Hey, back panel's free. I'll close the front panel. Come on. Nearly there. What a mission. Yay, we got it. Wow. Man. That was not fun. So I'm going to put the other screw back in again before I forget about it. And you're all gone blind again. Right. So after a massive amount of effort, a lot of tinkering around, us trying fitments and things, figure out how to get the board out. It is a mission. You have to basically strip all the vertical riser out and everything like that. So you got the board, basically the bare board now, like this. So the transformer's attached to the board, that sort of stuff. You have to remove the heatsink, the rear panel screws. There's 2 screws in the rear panel. Take those out, so it frees it from the side panels. And then you got to try and slide it forwards a little bit. You got to lift it up a bit, and then slide it forwards to push basically the power switch as far forward as you can. To get it forward, to create a gap at the back to get it around this little bracket here, because otherwise you can't get the board out. Otherwise you've got to get the board around this side of that bracket, and then you can lift it and lift the board out with the rear panel. It's a really tight fit. It was not a good design. So anyway, we've got it out. Now we can actually try and fix these caps. Yeah, I'd just like to explain how I actually got it out, because in case someone else is watching this video in the future trying to do the same kind of repair and they need to figure out how to get the thing apart, so I want to try and put it in there to cover that. So let's just move this out of the way so I can work on this. We'll balance it on something. You know, balancing on stuff that could possibly go wrong. Be fine. Right. That was not an easy thing to get out. If I just didn't have those 2 screws in the bottom there. If they had screws on the sides, it would have been easy. Never mind. So, board looks really nice though. It's pristine. No one's ever been here, I don't think. Probably because it's too bloody hard to get into it. Okay. Wow, that was definitely a challenge. Yeah, because this side chassis, the side chassis are attached to the front panel. I suppose one way to do that would have been to remove the nuts on the back of that side rail. It's 4 of them, you can only get to 2 of them really, so even that would have been really hard to try and do. Now I think the way I got it out in the end was the way it's meant to go. If they just added slightly more tolerance, you know, another millimetre would have made all the difference. Seriously. Anyway, never mind. So, got to get these caps out. I'm half tempted to take that rear panel connections off, so I don't stress the wires. I might do that. Get that driver. Now, what size do you reckon they are? Is it this one? Probably not deep enough. That one. There we go. Nut driver. So I'm going to take these rear panel connections off as well, just to avoid stressing the things. Nut drivers, brilliant things to have. Highly recommend you get one if you don't already have a set. This particular one is a 8mm. Fits on those perfectly. Well enough anyway. Maybe not perfectly. So now clip those off and get the back panel out of the way. That filter's made in Barbados. Interesting. In 1984, 14th week, 84. And there's the setup inside it, and I'll show you that. There you go. That's the actual filter. So it's got 3 caps in it and a couple of inductors. Common mode inductor with a ferrite. Okay. Let's do his caps. Okay, you better hobbyist, thanks for dropping by. Long reach nut drivers are more valuable, yes. Well, the ones I've got are usually good enough. I've only had a couple of times that I haven't quite reached. I'm not liking the way this transformer's bent over. See this? It's been tipped. It's like a rivet, so it's just hinged over a little bit. It's fine. See, it's fine now. Okay, well, let's see what we got here. So we've got a 1000 microfarad 10 volt. Sorry, 10,000 microfarad 10 volt. So when I find out I actually have the cap I need after all this. 10,000. 10,000. Maybe this one here. So looks 10,000, 16 volt. There we go. There's one. Nichicon. Looks like I'm getting a bit low on caps. And then what else we need here? We got 15s, 1500s, 25 volt, 3 of those. I've done 1500. We've got 2200s. Rubicon, 50 volt. Yeah, 25 volt. There you go. It's got the same voltage. 105 degree rated. Not sure what brand these ones are. Oh, match heater. Okay. So got one of them. Also got Rubicons 35 volt. Maybe I should do 35 volts. I like to put all the same ones in. So I've got them all the same. See, I forgot. I like to put a set in if I can. So it always matches, you know. I'm fussy like that. It's not my OCD or anything. Here's another one. And another one. So there we go. Got 3 of those. That's a set. That's good enough. They're physically smaller, but that's fine. So that's those ones. And then we've got a couple more on the back. In fact, one of those is actually looking a bit bulged. See that front one there is looking slightly bulged. It's 100 microfarad. Yeah, it's not looking quite right. It's not bulged at the press mark though, but it's bulged at the sides. So I think that one may be on the way out. So it's 1000 microfarad. Sorry, 100 microfarads. Got loads of 100s. Trying to see what voltage it is. Also got those other ones next to it as well. 6.8s. Let's have a look here. Got a few of those around. $135 volt. Okay, and we've got 6.8s at 25. Got a bunch of those around. 4 of those, is it? 5? 5 of those, okay. We'll do all of them. So 100 microfarads. If I get the drawer open. I don't have any 6.8s. So it's a 35s, wouldn't I? That's 100 volts, a bit much. If I can get the drawer open, it'd be great. I'd be able to get the whole thing over here. It's got too many caps in this drawer, which is a good thing. I'm going to use some. Right. So I've got 10s. I might have to use 10s to the 6.8s. So 35s. So 100. It's 25s. Don't do that low. Okay, I might do 100s. I've got too many of those anyway. Go with 2 of them. Maybe I'll get the drawer back in now. A 100 would have a slightly lower ESR as well. The larger the cap, the larger the voltage, the lower the ESR will be. You know, I've got them. I've got the mailbags. No 1500s. No, I haven't got 1500s. Or 6.8s. I'm surprised I haven't got 6.8s actually. I've got some axial 6.8s, but not radials. So I have to use 10s. That's fine. I'll use 10s. And they were rated at what? 25 volt, weren't they? These are 50 volts. Make sure we get the same type. Well, that's 63, it's not quite the same. There's a 50 there. I want to make sure I've got the same ones. Like I said, I'm fussy like that. I need one more 50. There's another 50, but it's not the same profile. That's a dodgy brand, so I'm going to put that in here. I think my fussiness is going to be a problem here because I want to have 5 the same, but I sort of think I don't have 5 the same. One's going to have to be different. Oh no, there we go, got it. Right. So 3 of those caps, 1 big one for that, 2 for that, 5 for those other 5. This one I find I actually need 6. No, okay, that's it. Let's get the desoldering going. Right. Put fresh solder on these first. Is there any orientation markings on the board? No, there's not. It's always nice to have markings. Okay, so negative to the left, negative diagonally up there, interestingly, negative vertically, negative vertically, negative to the left, negative vertically, vertically in those, and to the left on that one. You got that? Might have to play that back later. Now I could just test these caps and replace only what's required, but that's not me. If you think that I'll do that, it's only I only do that if I don't have the parts available. Yeah. If I don't have the parts on hand, then I'll consider doing that method, but otherwise, no. So she has a square pad. Now let's put in fresh solder on. So a square pad should be a positive then, I think. I got that right. It's usually a good indication, but not always. Double checking they actually match what the signal capacitors. It does. Sometimes they're wrong, so don't always assume that's the way to go. Alright, let's replace all the 1500s first. Not got enough slack on it, so I'm trying to leave it out. Come on. No, there's no silk screw under the caps. Don't even have that. Let's walk this one out, it might be easier. Sometimes it works better one way than the other. Those all out. So let's pull those three 1500 microphone caps out. I'm going to replace those with 2200 because that's what I've got. 25 volt and these 5 volt as well. Yeah. Higher ratings, high capacitance levels. So I put these ones in, and that's those ones at least. I've got to do quite a few more after that. Also, you always check polarity. You don't want to put a cap in wrong. Put a cap in backwards, you have a problem. You find out pretty quickly usually. And usually there's a clue about which one it is. Alright, that's those in place. Replace all the parts, yeah, just replace everything, every single IC, yeah, do the whole lot. Yeah. Well, now I know how to get it out. It wouldn't be so bad next time, you know. Half of it is figuring out how to get it out. Anyway, that's those four. Let's do the big one. I might record this. Big one's right there. Now, in fact, the big cap out one is bulging, so it's just here somewhere. I think it's those two pads just there. So let's try and wiggle this out. Just clearing the holes out as I go. Negative and downwards. So there we go, 10 volt. $10,000 at 10 volt, and I'm putting in a 10,000 at 16 volt. go. So what I might do now is actually solder those ones in before I do the smaller ones. Otherwise you end up with all these leads sticking out everywhere. If I put flux on this board, it's going to make a mess. I might try it without flux first, see if we can do it without flux. Looks like it's going to go alright. Because it's double-sided, I've got to try and get the heat right through the board and get the soak to the other side, so it also attaches to the other trace. It's barely okay. Also, being a capacitor, you don't do it too much because you can actually damage the cap if you overcook it. So don't forget the heat goes right up the legs into the cap. So there's a bit of a trade-off there about instinct. Which one do you think you need to go for? How long? I'm also watching for the solder disappearing, so like the level will drop down as it goes through the board. As it wicks through. So I'm kind of watching for that happening as well. Yeah. I'll clean the board up afterwards once I've done all of them. That's the first set. What I might do, because this one's quite standing off, it's the leg spacing wasn't quite the same. So this one's a bit wobble, like the original one. The original one was the same actually. It wasn't sitting right down. So I might actually put something on the board here just to help support it. Some liquid something just to help attach it to it. This is not worried about because they're pretty small, but this one's quite big and heavy, so I might still do a bit on that. But I'll do it afterwards. Maybe if I don't forget. Let's do these ones over here, these 100s. So those are 100s at only 85 degree rated as well, 35 volt, and I'm putting in 100s at 100 volt because that's what I've got, which is similar sort of sizing and stuff. This leads me to the 5 smaller ones now. So look, you do both in your layouts. Oh yeah, I always silk screen any of the boards I design. It's always silk screen, so it's shows where the positive is. I hope I don't get it wrong. Yeah, there's a little bit of flux in the solder. It's quite a small. It's quite a thin solder. It's not super thin. It's what size is it? 0.56 mil. So it does have a little bit of flux in here, not a lot. Yeah, some Texas have reverse footprints. Yes. The Adventist multimeter I've got there, 8.5 digit multimeter. That's got some reverse footprints in it. And they actually manufactured them wrong as a result. They actually had them backwards from the factory. That's quite interesting. Alright, let's get these smaller ones out. Now I'm pulling the cap out and checking to make sure the square pad is on the positive. Just in case. That's tricky. It's right by the heatsink. I'll try and hold it with tweezers. I can't get my fingers in there. Come on. I think I've clogged it. Yep, clogged it. Come on. Here we go. Oh, that sounds awkward. Just can't really get my fingers down there. There you go. Side on, that works. Come on. Melt. Taking too much solder off the first time again. Put some back on. There you go, it's fell out. Not sure to unblock that one. This one there is not quite clear. This one here. Two more. Not much longer. Let's take this one first. Right, I think that's all of them. Yep, let's put the new ones in. We'll check them all after this as well, as I've got this thing sorted out. Hear a fan, can you? Yeah, that's my soldering iron. I'll turn the desoldering on off. That'd be something. But the fan you can hear is the soldering iron. Sorry, which is near the microphone. It does actually ramp down when it's not being used, but it doesn't do it straight away. So the next thing I want to work on after I've done this thing, which looks like there's not much to do on this, assuming it actually works, of course. We'll find out once I get this bit done. Is the capacitance standard. This Russian capacitance, well, it's not Russian, it's Soviet. Predates Russia. It's Soviet capacitance standard. So I showed the mailbag before, and really want to sort that out because it's big and bulky. It's in the way on the floor, in our pile. Right. So check them all around. Good. Yep. Right. Right, I'll turn the fan off now because we're probably done with that. Recognises Ian. It's your fault. Right, let's do some cleaning up. Fall off. No, other way. I've always considered the option of using Q-tips, but the whole option of trying to get strands of cotton back off again. I don't know, I've tried them in the past, and they don't work okay. Some people use Q-tips instead of this method. I'm not really sure which one's easier. I think sometimes the Q-tip method does actually work better. Right. I think that's done. Let's put it back in. I should check these caps afterwards. Yeah, I mean, I've got cotton buds, and I've got some like these little foam ones, which are good for doing some finer stuff like lenses and stuff like that, a bit more gentle. And I've got some stick type cotton buds as well for getting to smaller spaces or doing some quite tight cleaning on, or robust cleaning I should say, between ICP and stuff like that. You can do that. Anyway, let's refit this thing. And make sure I do it in the right order, because the last thing I want to be doing is taking it apart again. Q-tips, yes. Cotton buds, Q-tips, what you want to call them. That does not want to fold back down. Why does it not want to fold back down? Because I pushed it. Right. So, I need to put this bit in and the rear panel bit in. I mean, getting it together like that is easy. I don't know, it's just that whole rear panel part which is a problem. They put slots in it. Well, if they'd slotted this down there instead, it would have been easy. You could have just lifted the board out, but because you've got to try and get this panel out at the same time. Check for solder. No, it'll be fine. The board looks alright actually, from what I can see. The board looks okay. There's nothing there I can see which is concerning. Hold on to this. Doing. It goes in there like that. That. Come on, pop through there. There we go. It's around there. And you missed the best bit. I don't want to clean the keyboard. Well, I'll see. I can get that keyboard out with this board in place. That can come out with a board in there. the thing is I've got to take all the keycaps off, and that's what makes that one hard to get out. So it means I take keycaps off, now I can get the board out. So if I have to do that, I have to do that. So I'm not worried about that part of it. That's okay. Set that back down. Make sure nothing's pinched in there. That's looking alright. Okay. Now, do you remember where the screws went? I'm not sure I do. That nut's come loose. Right. Put those ones in, and I can put that board in place. $1,000 years later. Yeah, it could be that. Need one more down there. Oh god, it's got like a earthing spring there for the casing. Keep catching it in my glove. I think once you actually know how to get this thing apart, it's not that bad. One of those, one of these. I think it's that screw. Guess we'll find out. Probably that screw. Get the thing in there. Do one there. So I've got a screw that goes through the casing. Make sure I'm getting the right screws. I'm not sure I am. It's a bit long, that one. It might be the right one for there though. Should pay more attention. How many screws do I get left out? Well, we'll find out, I suppose. It doesn't help when I drop them on the floor. Come on, where's the hole? Just put this back in now actually. Get that out of the way. Case screw? Not sure it is. Not sure it's a case screw. It's not a different one. That's a case screw, definitely. Put these back in again. So you know where the screws go. Great. Did you watch the video back? So what we've got to do now is tighten that one up because that's just a nut. That's aligned. That hangs on there. We'll do if I can get it right. This glass could be a problem. Just get onto it. Ah, dear. That needs one down there. Oh, that's the top one, this one here. Yeah, sometimes if I've got stuff which sits around for ages, I'll actually do it in little containers I'll put screws into. It depends on what I'm doing, or I might put in a little bag or stuff like that, or sometimes I'll put them in a bag and put them inside the project I'm working on. Depends on what I'm doing. Okay. Goes there. Nearly there. Famous last words, isn't it? In the right screwdriver for a start. Connectors back on again. Actually, put some deoxit on those. Tiny little bit if I can try and get dribble at the end. So it did run down. Okay, condenser's back on, wiring's back on. Everything's back in place. Want to secure that cap. Got a video about this. So it's basically reassembled now. It's got to do a few more bits. Got to put that bottom panel back on again, put the top cover on. I think everything's back together. I don't think I've missed anything yet. What I'm going to do is I'm going to put some of this liquid electrical tape underneath this cap here to help brace it. I'm going to try and lean it away from that heatsink to keep away from it. And I've already kind of done the same thing with these ones already, trying to lean away a little bit. But this one here I'm going to lean away quite a bit to try and stop it from aging prematurely. That camera picture's gone weird, isn't it? It's all long. Leave the top camera off so you can see the smoke. Yeah, well, yeah. Put that under there. And then put it away. It's quite liquid. Trying to make sure it doesn't just run away. Okay, whilst that's sitting like that, let's put this next panel on. Yeah, this picture's gone wacky. I've had problems with this. I've been having issues with my computer. Well, kind of. I rejigged everything, and the USB power powering the HDMI converter is a bit weak, and when it loses power a little bit, it gets a bit low. It does this, with the converter's not actually powered properly. Let me just plug that back in again and see if it comes right. There you go, that's better. Be ironic if it otherwise needs a power switch. That's so true. It could actually happen, couldn't it? That could actually be a thing. Needing a power switch after all this. I've got to take it all back out again. That could happen. Right, there's one screw there. Great, it's going. Look at that, worked. So I figured out a technique to get that cover on. That's the other thing of doing videos, is that I can see how I pulled it apart. I've actually had to refer to that before when I'm working on like mobile phones, stuff like that. You go, oh crap, we got 20 screws and all different lengths. Because that's the thing. Right, we just got to really power this up, I think. Let's just make some room. Should we check the caps first? Let's check the caps first. No, we're all dying to know what they're actually like. Let's do this. Oh, we'll just push the button. Forget that. way. You want to do ESR. Could look at dissipation too, but ESR is a go-to one, isn't it? Right. So let's check the capacitors out of interest. So this is the 10,000 microfarad 10 volt. Yeah. Let's make sure I've got a decent connection. Yeah, there we go. So that's actually lost half its capacity. So yep, definitely bad. This is a 1500, I think it is. Yeah, 1500 25 volt. A little bit low. ESR is not looking too bad, 0.1. Same again. Yeah, okay, not too bad. Same again. Again, not too bad. It's got slightly higher capacity. So quite a broad range here across those ones. This is a 1000 microfarad 35 volt. Yeah, I think that's dead. What do you reckon? 58 microfarad. 18 ohms. Yeah, that's gone. This is why we recap these things. Even though it looked fine, no, it wasn't. This is another one the same. It's getting 50 at 24. Yeah. Both of those are dead. Next one is the 6.8s. 25 volt, I think they were. 7.4, 18 ohms. A little bit on the high side, but it's a small value, small voltage. So they are going to be a little bit higher, but I think that's probably no good. 21 ohms, yeah, 7.2 microfarad though. Capacitance is looking okay, but the resistance is looking a bit dodgy. 19 ohms, 7.2. Yeah, these, I mean, generally my experience has been that smaller capacitors tend to die. 17 ohms, I mean, that's marginal. Last one here. Smaller caps seem to be more prone to it anyway. 23 ohms, yes, dead. So, yeah, I think basically, you could say all those caps are bad. Right, so we've got two inputs, voltage input and millivolt input. We'll just check the voltage ones because that's an easy one to do. That's plugged in, yeah, that's all good there. So I don't like the way this wire's sitting here. So my transformer wire is resting against the heatsink, I don't like that. So I need PVC. Okay, let's get a source. I don't know what source we could use for this. Don't know. Are these standard spacing? Yes, they are. Brilliant. Okay. So that's fine. So, ready for magic smoke? Please get this in a shot as well so we can see what the power is actually like. Power switch is off. Right, let's power this thing up for the very first time. I'm confident now the caps are all good, at least the ones that matter. There's tantalums in here, so we could still have an issue. Could be a shorted tantalum, you never know, it's a thing. As long as the power supply is good, which is part of the reason I wanted to change these caps, the tantalums will probably be good as well. And the problem is, when you get a lot of ripple on a power supply, go and take your gloves off now, you can go. What happens when you get a lot of ripple on a power supply, it puts a lot of stress on the tantalum caps. Tantalum caps don't like a lot of ripple. I mean, they are obviously a smoothing cap, but they like impulse noise, not shake noise like that, like an AC ripple waveform. So they don't like to be stressed. And if you've got a lot of AC ripple and it's close to the voltage on the cap, these tantalums tend to be a bit close to the actual voltage they're running on, the actual ratings they use. You really want to double it at least, ideally triple it, right, to get plenty of headroom. So we're nowhere near the maximum voltage rating of the cap. Because if you've got an AC ripple coming through and you've got, say, a 50 volt rail, and you've got an AC ripple coming through, you could be getting 15, 20 volts AC, right, on a 15 volt rail. You could be getting 20 volts AC easy. And if you've got a 25 volt cap, you're getting a bit close to that margin. And when they're getting a bit old, that's a real problem. I've seen them blow on power supplies where they shouldn't have blown purely because of AC ripple. Because the AC ripple was getting really close to that tolerance. So I always give them plenty of headroom. Anyway, you really want a PDVS2? Somehow there's no money. Yeah. I've got this one because Ian was really generous and he gave it to me for free. Because he sent it one to me to review and try out and bug test basically. And so I've got this because I didn't pay for it. Alan was Alan. What had done it? Alan, I want to call Alan again. I did that again. Ian was really generous. Yeah. Anyway, let's power this thing up. We'll cut a bit out because I'm live streaming and recording. Right. Power on. No current draw currently. Good sign. Means the filter probably is not blown yet. Just give it a minute to see if anything happens. Okay. I haven't checked the fuse. We'll see. The fuse is after the filter anyway, but you know. Anyway, let's push the button. Do we have power? We almost have power. I forgot to plug something back in again. I forgot to plug the display back in. We'll try that again. Now you have a display. Yeah, we'll check the fuse. Current draw is 13 watts. 71 milliamps drawing on AC. That's looking fine. There's nothing horrible there. And we actually have a reading on display. So that's looking promising. So do say 20 volt range. Ranges are working. So yeah, that's working, I think. Is it? Wasn't it? It's changing ranges, so it's responding to the buttons. High res mode, whatever that does. Guess it does high res. Zeroing, yep. Filter, damping. Okay, all the buttons seem to be working. That's a good thing. So let's zero that. Let's plug the PDVS2 mini in. Careful where I stick my fingers. Turn this on. Let's do 1 volt. Well, it's reading it. It's slightly down, but then this has still got to warm up. 5 volts. Yep. 10 volts. Well, it's working, but it seems to be out by quite a bit. Okay, let's go down to 1 volt. It does have a LM399 reference in here too, so it probably needs to be warmed up too. So 1 volt is reading over on this range. So this range is reading high, and this range is reading low. I don't think that's a reference problem. I think that's a calibration problem. So that is at least working. So let's go down, see 100 millivolts. That's looking good there. 2 volts, again reading high, 200 millivolts. That's off that input. Let's change connections. Actually, before I do that, let's go up here. Let's do 10 volts. Let's do the higher ranges, see if they're working. 10 volts net range is working, and our net range is working. Great. So that all those ranges there are working. Let's check these lower ones. This is this ball down the side here, this big can on it. So that's a lot of thread to do up. Let's keep going. I'm into it. Right, drop the voltage right down. Let's do 1 millivolt. That's safe across all 3 ranges. And we've got this weird setup on this cable. We'll just plug into that. Convenient, but weird. Okay, so on 2 millivolt range, get an overflow. I'm doing 100 millivolts, not 1. That's why I'm doing 100 millivolts, not 1 millivolt. 100 millivolts. There we go. So that's working. That's really good, actually. Let's do 10 millivolts. Sure, I could have done it a quicker way. 10 millivolts is a bit low there. That's working there. Reading a bit out though, but probably within range. I don't know exactly what this output is. I could check it out. I actually need to hook this up to my 8.5 digit meter and actually do some calculations what those actually end up being. But it's working. Okay, do 1 millivolt. Again, I could have got there a better way. 1 millivolt. That's also working, but reading out. But it could be rounding on this thing because this is a digital analog converter. Great, it works. It works. I'm happy with that. Now, how stable it is, you see it jumping around us then. Put a filter on there. Does it help? Not really. Damping, whatever that does. I guess damping is like an averaging. Let's do high res. Extra digit. Nice. So this is basically a 6.5 digit meter. Alright. Well, let's go back up to a reasonable range and check for something which is more or less known or less noise prone, I should say. Back to 1 volt. Yes, that's definitely doing damping there. Look. Turn it off, straight to it. So yeah, that's like an averaging. But it needs calibrating. That's fine. I can do that. I'm not going to do that now. I'm not going to do that because it needs to be warmed up for a few hours and that sort of stuff, you know, at least, because it's got a reference in there. So I can hook this up on my other test gear, my calibrator, the other side there, and do that later on. Could be connection to the leads. Yes, exactly. Because these leads are a bit, how you doing? It could easily be. Yeah, because these leads are a bit like this. This can be picking up noise in those low levels. They're not ideal for that. Really, it needs a different kind of connector and different lead setup for those doing these like really low levels like that. But it works. That's the main thing. Hasn't blown up. There's no magic smoke. And it just needs calibrating, and that's not a big deal. Now it's fixed. I can send it to you. Who's looking for keyboards? I don't know. I don't remember seeing that bit. Okay, cool. So that's out a little bit. My 1 volt on here is actually, I think it's like, I think it was like 6 microvolts high. So that's really, you know, a fair bit high there. But that's alright. It's going. That's the main thing. Whether I can calibrate both ends of the scale out for linearity, I don't know what linearity is actually like on this thing. But yeah, that's alright. It goes. Happy. really need another drink. Probably all the talking. If I can get another one of these connectors, I can make another set of leads up. What main thing there's a few of these on eBay at the time I was looking at this thing, and I think only 2 of them had these connectors with them, and the leads. The other one was much more expensive. This is a cheaper one. So that's fine. I always buy the cheaper ones if I can, because usually there's more wrong with them, which means there's more things to fix and more things to do videos about. But yeah, it's an easy part of disassembly. Disassembly is a bit of a pain on this thing. Yeah, I won't calibrate it now. I'll do it later on. I'll do it by myself. Bore you guys with it. I'm sure it'd be tedious going to the manual and trying to find it all and figure it all out. I'll do that myself later on. And I've only got 2 screws left. Guess what? I didn't have any extras. I didn't get it wrong. It'll fit next to your 192. Actually, Ray, I think you should send it to me, mate. I think you should send a 192 to me, so I've got a pair. So you've got the high voltage stuff, and I wonder this does the high voltage as well, doesn't it? Well, that's a DMM. It does this, that 192 that did AC as well, wouldn't it? Would have done, I expect. It's obviously only DC. So that's alright. Now, what am I going to do next? Apart from get a drink. I think I need to look at this capacitance thing. I'll close off the video. Oh, I need this. I should have made use of this one earlier. That was really slack of me. That's that done. Now, I should have actually used this button earlier on.
It's always a capacitor.
It's always a capacitor. And
Click subscribe right now, quick, before you forget.
just like my desk says, subscribe. Click like if you liked it. Other videos down below. Don't forget to subscribe over there. Patreon support link over there. Patrons help me to buy things like this. So the money from Patreon goes directly into buying broken test equipment to do videos about. That's what I use the money for. So if you want to help me to make more content about these kinds of things and bits of equipment, you got a Patreon. It's only like a couple of dollars a month or a bit more if you want to do a bit more than that. A couple of dollars is all it is at the minimum. So it doesn't cost you much at all if you want to help support the channel. The more people that do it, the more bits of gear I can buy and the more videos I can produce about fixing pieces of broken gear. So if you want to do that, it's great. Right, catch you later. Right, done. That's that bit. So let's put this to one side. What should we work on next? So I've got this capacitance thing here. Or should we do the tube tester? I forgot about that. Could you do the tube tester? Oh, mine just 110 volts, so I have to be careful with that. I don't know. Tube tester or standard capacitor? I'll have to do a vote. I'm going to do a vote. Engaging the audience. Cue it. No, it's not one. No, cancel that one. Clicked on the wrong thing. Poll. There we go. Poll started. cast your votes, and then I shall be back very soon. I was going to go and grab myself a drink. I'll be right back. Can of V I started earlier. I don't drink much V, but it's convenient for now. Okay. First live stream you stayed to watch. Well, welcome and thanks for hanging around. Hope you found it interesting. I'm gonna potentially do one more thing. Yeah, I tend to do streams for quite a long time. Depends on my throat is usually. My throat's getting a bit sore now, so. But the next thing I've got to do shouldn't take that long. Assuming it's the capacitance standard, it won't take that long. If it's the tube tester, then it will take a bit longer. We'll see how we go. It's normal for me to it's normal for me to stream for at least 4 hours. Did a cell phone on live stream, did I? I don't remember now. What was it, an iPhone screen replacement or something? Battery replacement maybe? I don't know. Buttons? Could be anything. And I've got this Datamon bits everywhere. I need to climb that up. When I got this Datamon, it had a little IC inside the socket. This little IC here. What is it? I think it's some flash chip or something. Can't read the damn thing. LC128. That's what was in it, in the socket when I got it. There's actually an interesting story about this Datamon. That when I purchased this thing, it didn't arrive. It was months and months, and it hadn't shown up. It was like 6 months, or 3 months, or something like that, and it just didn't show up. I got it from the USA, so it shouldn't have been. Should have been like a couple of weeks, maybe a month. And it was, I think it was maybe 3 months, and it hadn't shown up. So I ended up doing a claim on eBay saying it's vanished, tracking disappeared. I had nothing. The tracking just stopped, disappeared. So I put a claim on eBay, got refunded, which is great. I got money back, and then about a month later, it turned up. Oh, is it 2 months later? It's ages anyway. It's months. Well, I started the stream nearly 4 hours ago. Alan sent me an email again, did he? Oh, Grant. Oh, it's one of the ideas I did, is it? Oh, okay. Where is the clarifier pot on the old Grant sideband? If I did a 5K shift to do the New Zealand channels and the Australian/American channels, there could be there's a couple of ways I did it. I did some different techniques over the years. There could have been a little circuit board in there with the little trimming capacitors on it, which does the 5K shift on each mode. Or it could just be a capacitor going across, or inductor across the crystal with a transistor switch. That's another way I did it. Yeah, there's a few different ways I did it. Sometimes I just shoved a capacitor across it and switched that in. That was good enough to drop it down. Depending on what people wanted, how fussy they were, if they didn't really care about sideband, I might just chuck a capacitor across to put it down to 5 kilohertz. It really depended. But yeah, I think the last things I was doing was a little circuit board which had trimmers on it. I've got one around here. I might have one around here. Let's see if we can find it. Might be here somewhere, if you're lucky. I'm not sure. It might not be in this drawers. It might be somewhere else. No, I think I've got them somewhere else. Oh, it'll be up in my PCBs bin. That's what it'll be. It'll be up there. But yeah, it's a little circuit board. It's literally like that big, and it's got some little trim capacitors on it. So each capacitor is tuned for AM, LSB, upper sideband. So each one's adjusted. There's a cap with 2 diodes. I'm using diode steering to pull the gap. Right. iPhone display. All right. How easy to make look? Well, iPhones are relatively straightforward. Well, the modern ones not so much, but back then those would have been maybe a 6 or a 6S would have been doing probably. Could be something else. Yeah. Let me actually have a look at something, Alan. Let me see if I can find something. So, what's the serial number of that radio, Alan? If you put that in there, I can look it up and tell you maybe what I did to it in more detail. I do keep records. Maybe I've still got it. Never should have bought a cappuccino machine. So you're saying it was a grant. So is it Union grant and President grant as well? This everything. Yeah, hold on. Let's go back to the email. Didn't specify. Do that whilst you're waiting for the poll results to settle down. It's a bit borderline right now. So, the old grant. Just looking at some other stuff here. If you excuse my distraction. Most of them I put down as union grants, so I've put them all down there. Uh, 3075. There we go. Ah, shit, really? Oh, wow. Okay, that radio was a special radio. That used to belong to a guy called Mike Boter, and he died. He was a work colleague. He died several years ago now. He just died suddenly about 8 years ago. And I actually did that radio for him. So that's actually a special radio. Yeah. So I'll tell you what it had at the time. Actually, I did this radio 10 years ago almost. Nearly 10 years ago. 9.5 years ago I did this radio. So I placed the signal meter bulb, TX RX LED, because I didn't have the right one. I had to bodge that at the time. Made it work. Added a 1K resistor to the AMC circuit to increase modulation level because it was a bit low. Tighten up the PCB screws. We soldered the PCB earth tag because it was cracked. Cleaned speaker sockets. Adjusted signal meter screws to help the meter because it was sticking. Hopefully it's not sticking still. Hopefully it's alright, but I actually got spares as well. So I also removed channel 9 matrix diodes and added it to pin 10, put it low, so pin 10 of POL from the channel 9 switch, and bridge channel 9 switch terminals together, retain channel selector function within channel 9 position. Yeah. Move reactor diode and put in series with 4.7 microhenry and 1 microhenry inductor to pull crystal down by 5 kHz. You use a transistor switch across the inductors, which is turned on when on 26 MHz to bridge across the inductors and increase the frequency back to original NZ band with a full realignment. There you go, that's my notes. Yeah, I'll shove it on the top screen. You can take a screenshot or something. Somehow. Hold on. Oh, it's jumping around. Yeah, we'll do that. Okay, I'll show this to the top screen. There you go. Got a screenshot of that or something. There's the notes from that radio when I worked on it before. There you go. It still sticks here. It was okay at the time, but tweaking it, because what it is, it's got some little pivot screws on a meter, one each side, one on top, one bottom. And what happens with it, oxidization and like aging, and get a little bit of surface corrosion on the connections, on the pivots, and they get sticky. And so if you loosen those screws just a little bit and do them up again, loosen them a little bit and do them up again, one side or the other, sometimes you have to do both, and it will free it up and it will come loose again. But it's not guaranteed. It's like a workaround. If you loosen it too much, the pivot will actually, or the meter movement will drop out of the pivot, and then your meter's knackered. Right? You've got to try and get it back into the pivot, and it's not easy. So that's what I'll do as a first attempt, is to loosen those pivot screws off and free the meter up that way. And that will usually work quite well. It depends on what sort of environment the meter's exposed to. Sometimes that's all it needs, because they were just a bit too tight for the factory or something, and then it's fine for everyone. But there's been times like that one, apparently, where it's not been good enough to keep it going. Where you could maybe try loosening it a little bit more, that might fix it, or the meter just needs replacing. And it's probably got to the point where the meter probably needs replacing now. And as far as the software I use for this is a website. So it's I have a database system on the website, and I log everything in that, so I can refer to it later on. For this kind of situation where I get a radio over again or see a radio again, I can see what its history is. So, and yeah, that gives you an idea of the notes I make when I'm working the radio. They're not always that precise. I mean, it's very precise, that one. I actually wondered what happened to that radio after Mike died. I actually wondered where it all went, what happened to it. So now I know. So my website, radiomods.co.nz, or one of my websites, that's the CB radio based one, and it has basically a lot of public information, but there's also a membership area where you can pay like $25 a year for a membership, and it gives you some high level access to stuff. Although I don't tend to update it that much. I haven't actually done that much on it for a long time. But the members area's got things like all the circuit diagrams, block diagrams, service manuals, things like that in it, which can be downloaded, and with some restrictions, stop people scraping it. But that's the main thing there. Because I think if you're working on a CB radio and you need a circuit diagram for it, you can't find a decent one. That $25 just for that one circuit diagram, if for membership, is worth it to you. Then you get all the other stuff. So yeah, that's basic. That's why I chose that value. But I don't really. I've got lots of information which I've still yet to put on there. I've got so much stuff to put on there, and it's well out of date as well. Like the actual design. Yeah, so it's the actual like the back end stuff is a bit old. The way it's one of the Radio Mods is actually the very first website I built. Give you some idea. And I've done some modernisation in the members area, but I've only done some of it. It's not finished. It's one of these projects which is half done. Multiple projects around here which are half done. That's just one of them. So I was trying to modernise it and actually allow for members to upload their own information as well. It does actually allow for that now, but yeah. You find a copy of my full website and members pics. Yeah, okay. I know there was a guy on eBay saying it at some point. I did get told about that some while ago. This is years ago now. Someone was selling it. They scraped it, which is why I added the restrictions on the site to stop people scraping it. And it logs everything. Like if you download something, my website logs it, so I can see you've downloaded it. Like I've had issues in the past where someone's become a member, downloaded the information they wanted, and then trying to claim a refund. So lots of refund requests through PayPal saying, "Oh no, I didn't. It wasn't what I wanted." But then I've got the records and the logs that prove they downloaded things off the website. Where you got this diagram, this service manual, this diagram. You downloaded these things, and the payment is for access to the members area, and they got access, so they got access to it. So I fulfilled my part of it, and then PayPal inevitably tells them, no, sorry, go away. And then I block them because they're being a prick. NZ quiet for CB yesterday is very quiet. Mostly truckers. Oh, I know some people around, but not really. I mean, I haven't used CB in years. I just fix the things when I have time. Anyway, so yes, that's that. Right, how's the poll going? Poll is 58% towards the capacitor. Been out of electronics for 30 years, are you? Okay. So true test that's 41%, 12 volts. 12 volts. Alright, well, let's look at the capacitor. Very active there. Ray, you were in the US, weren't you? Was that right? Yeah, okay. Ireland, right. Oh, it's active in Ireland still, is it? Okay. Right. I know it's still pretty big in the US. I mean, most of my CB stuff was in the UK when I lived over there. Anyway. Right, let's get this capacitor thing on the bench and we'll look at that. Let's do that one. Flat out since the first lockdown, really. Cool. Now, here's one part of the capacitance standard. I don't think I'll be fixing that part. I didn't actually have a plan for this, and I'm still debating doing it. I may or may not do it. This thing weighs a ton. Anyway, probably about 15 kilos, I suppose. Here she is. Stick on its back, I think. This old beastie here. Yeah, CB's still big in trucking, yeah. Most of it's just truckers, mostly, over here. Most of the CB work I used to do was for truckers. They'd bring radios in, want to convert to these in channels, and I'd convert them. I did a lot of that. Repairs as well, obviously repairing stuff. Right. I can't need to do a video on this. I'm going to arrange this setup. Now, I did show this mailbag before. You may or may not have seen it if you were around then, where this handle was bent and damaged when I opened the box up, and as soon as I touched it, it fell off. So that one's broken off completely. This one is bent, but it's still intact. Now, what I was thinking about doing on this thing, let's change views. This is a bit awkward of view. That view. So what I was actually planning is actually making a whole new side and getting, well, basically drawing up a side in CAD and figuring out that part of it. It's all wonky, yeah. Yeah, I wanted to try and draw that up in CAD, and I've started doing that. A program called FreeCAD. Part of it is learning how to use FreeCAD. I haven't used it before, so I'm trying to get to grips with that as well. So I've like drawn out the base shape, like the actual outline and the handle outline, that sort of stuff. And I've got to try and figure out the internal dimensions and how the mounting points. This panel here comes off the side, and I'm really tempted to try and get that drawn up in CAD properly, you know, as properly as I can do it anyway, and see if I can get that made by PCBWay, because PCBWay also do CNC machining. So if I can get it done in FreeCAD, I might be able to get side panels made by PCBWay and replace both side panels and get it nice again. And if I can do that, I may be do something like emboss Defpom on them, or something like, you know, some kind of tacky tagging or some kind. But that's why I haven't actually done anything on this yet, because I was wanting to get that CAD design stuff done, actually have that as part of the video as replacing the side panels. I mean, I can still add that in. I'll do that as a second part maybe if I do that. But yeah, anyway, it's an interesting beast. Well, if I try to 3D print a side for this, or parts for this, they wouldn't be very strong. And this thing is about 15 kilos, right? So I wouldn't really trust it. And I like to have both sides exactly the same. And it'd just be nice to have proper sides on it, which are robust. I mean, the other way is to just cut this handle off and have no handles on it, and just maybe put some filler in here and fill these gaps in and make it, paint it or something, and pretend it never had handles in the first place. That's an option. I did consider that, but the other thing I could do is still cut that one off, because it is bent anyway, and let's make a smaller piece, like a smaller handle which bolts onto these screws or something like that, just here, instead of a whole side panel. Depends how complicated this side panel ends up being. I've got probably 25% of the CAD done on that, maybe less. I need to sit down and get time to finish doing that. Cracking down on power units. Yeah, well, yeah, when the FCC is supposed to be 4 watts max, isn't it? but they've got, you know, making 100 watt radios and 50 watt radios and stuff like that. It's a bit amazing even allowed to sell them like that. They're supposed to be export radios, aren't they? And yet they're sold locally. Which picture you printed faster? Yeah, well. Alien's Harder World, yeah, that's not Sonocan World. Well, the thing with PCWay, that they do the CNC machining, but PCWay is one of my sponsors. So there's actually a really good chance if I can get this drawn up and get it to, you know, something which I know will work, I don't want to make it twice, I may be able to get a sponsorship with PCWay, so it doesn't actually cost me anything. I can send it to them and ask them to make it as a sponsorship thing, and they'll likely do it. Depends on what its, you know, value is to them, and it might be too expensive, and they might say, "No, it's a bit much," but they've never turned me down yet. So anything I've just put through, they've said, "Yeah, sure." So there's a good chance that I could do this, and it won't cost me anything, only my time, which is the motivating factor of doing CNC. If it's something I have to pay for, that's going to cost hundreds and hundreds of dollars. In that case, I wouldn't go that way. I would do something else, like cut the handles off and fill them in and make it look nice without the handles. Yeah. Yeah, so that's the plan. Anyway, that's the benefit of being a YouTuber. You get sponsorships, and you can get things done for cheap or for free in some cases. That's the benefit there. It's one of the few perks. You put a lot of money into this. Like, yes, I might be getting it for free potentially, but there's lots of things like I had to buy this thing in the first place. I think I paid. I think it was about $600 for this, or $400. It was about $400 I paid for this. All right, so you know, each piece of gear I buy is a big chunk of earnings, and well, I actually finance my channel myself, so the Patreon memberships, YouTube memberships I have, which contribute to the channel, they help certainly, and but a lot of this sort of stuff I'm financing it in my pocket, so I'm making money on YouTube. I'm not actually making any money because it goes back into it, and money for my day-to-day, you know, my day job goes into it as well, and that subsidises it by quite a bit. It's quite expensive. Your channel as well is really small. Yeah, we have to start somewhere though. Fiberglassing, yeah, I'm not that good at fiberglassing. I've done fiberglassing, I'm not that good at it. It's just not my skill set. Right, that's enough waffling. We need to do something with this. Let's get the camera turned on. And we'll change views. Interesting, it's got these interesting plugs in here, which I'm not sure what size they actually are. Like these connectors, they're not 4mm. That almost goes in. Is that the right one? I'm trying to figure out what size these things are. It's got weird connectors. They're not 4mm banana jacks, something else. They're bigger than 4mm. And that screwdriver there doesn't quite go in there. It's close. It's almost that size, whatever size that is. Casting's easy if you've got the right gear. Yeah, okay. Yeah, I mean, I've done fiberglassing, but it's when I was doing car audio many years ago, and I was making speaker pods for the front doors, and I did fiberglassing for that. It worked, but I was covering with vinyl after that anyway, so it's purely to get the mechanics built and the mounting for the actual speakers. So this camera view has gone wonky again. Let's fix that. This is not doing very well. I think I might need to add a supplemental power supply for this hub. Okay. that's better. Well, I used to do competitive car audio. I had one of the best cars in the country for years. High quality car, it's not like the volume, well, it was bloody loud as well, but it was about quality of the sound. I had one of the best cars in the country for many years. So I built my own speaker pods to get the sound how I wanted it. Right, adjust this lighting slightly. Might be better. Put this back in the picture as well, I think. Yeah. Let's do that too. The Trucker magazine. Oh yeah. Yeah, my car got featured in magazines and stuff as well. Been on TV and things like that. Yeah, anyway. Another lifetime ago. Different hobby. So today I'm going to look at this thing. Now, I showed this previously in a mailbag many months ago. And I showed it arriving. I did some basic testing on it to prove it actually did kind of work. It's got decade capacitance, right? So it is indeed 10 steps on each one, right? And this thing does basically 1 microfarad to 100 microfarad in these, and it also does whatever that is 0.0001 to 1 microfarad on these. Okay, so that's 0.0 microfarad. So these are obviously the decade parts here as well, so you can tune them in. And these have got interesting terminals. They're not actually 4mm banana jacks. I'm not quite sure what size they are. I haven't figured that part out yet, but they're not 4mm, which is a shame because you can't just like get leads and plug them in. If I get my Fluke here, I did actually find a problem with this at the time. And I might have accidentally fixed it because I was tinkering with it, and I think I might have fixed it before I actually meant to. So let's stick the Fluke over here, and let's shove it into some terminals. So shove it in there like that. That's 40 microfarad. It's not showing up. Can't do it. 30. Or maybe it's the way I'm holding it. There we go. Showing nanofarad. Can't do that higher capacitance apparently. Maybe it can, maybe it can't. No, it can't. 10 microfarad. No, this thing can't read them. There you go. 4 microfarad. You can read that one, but it's way off. 3, 2, 1 is right, but this isn't great for that. I think we need a different meter to measure these capacitances. Let's see how I can do this in a sensible way. I'll just try a different meter. One that's maybe got better range. Don't actually remember what these things can do. Don't remember the specs. Might be wasting my time with some of these. Let's try this one. Of course my laser's tangled. Right, let's try 40 first. He's trying to read it. Probably not good connections either, that's probably not helping. Come on, you can do it. Or not. Okay, let's try the 20. Oh, sorry, let's try 10. No, that's not a good connection. Can't really do it. I bet you can read the 4 though, can't it? But it's really not doing it, is it? Forget that one. Now I've got my DER multimeter here as well, which could be an option. Let's try Bowman. So you can do 10. Start with 10. I think the dirt in these connections is really causing problems. Yeah, these are not really working. Let's try 4. I mean, it should be able to read them. 4 getting 2.8. I mean, this is pretty useless. I did read them before. I remember what I used it to actually read them with. No penalty. Now I've got the DER, but it's the clip leads, which I think I couldn't get in there. Try and remember how I actually ended up doing it. That might be the only option. Well, there is one other thing I could use, actually. Let's do that instead. Which is probably going to be a better way of doing it, to be honest. Let's rearrange everything. So I'll try and get this drawer shut. We've got the ESR 70, which I think can probably read them. Let's have a look. Maybe this is what I used last time, I don't remember. It's months ago now. No, it's not liking them. No, this isn't reading it. Oh, I did read it. I have done it. I've tested them all. I just wish I remember what I did to actually read them. Now I've got this. Let's see if I can get these leads in there. If I shoved like screwdrivers in there and clipped onto that, I might have done that. I honestly don't remember. It could be what I did. Let's whack a screwdriver on there and whack a screwdriver on there. I think there's something funny about these connectors. Let's try the 20. Okay, I'm getting 20 on that one. Right. Okay, I'll show you that. This is a bit of a clunky way of testing it though. Not liking it. Right. So I'm just trying to measure these capacitors, but it's really awkward because I don't have the right plugs. So I'm kind of just messing around trying to find a solution that will work. Because I do know I have measured these before. I've actually done it. But I'm just trying to remember exactly how I managed to actually measure them. Because they do need to be just right, otherwise you can't get a connection. There you go, I've got a connection in that one there. 20 microfarad, there we go, that was working. But I remember when I was going through these, testing these before, I couldn't get the 10 microfarad to work. It always showed us as being a short or something like that. I could never get it to actually register. Let's try the 30. So we get the 30 to work. Yeah, I can't get that bloody connection now. Come on. There you go, 31. I got it just then. And it's the 40. I really need to get the right plugs for this. Some kind of plug which I can just plug in and then use. This is really not a good situation. This one's supposed to be doing 40. But originally when I got this thing, I did manage to get measurements out of all of these connections. I just wish I remember exactly how I did it in a nice stable way. And I did find the 10 wasn't working. It was basically shown as a short. Just have a word about the rest of it, I suppose. Yeah, what size are these bloody things? I really want to figure that out. Yeah, I'll have to figure that out one day. Somehow I'll figure that out. Right. Anyway, what I did before when I was looking at this, and I found out that 10 was basically shorting out, I did actually have a sneak peek inside, and I think I found what was wrong with it at the time. So I may have half fixed it already, but I'm going to show you. So let's turn it upside down, so it's facing back there. Got these two screws here, got to take out. There's the panel, which you can see is extremely badly dented and curved, and yeah, it's just like a mess. That really needs straightening out. It's been dropped Now, when I got this thing in the packaging, it wasn't packaged that well. Now, there was some debate about whether it is repackaged or not. I did get a partial discount from the seller in the end because I did make a claim and said, look, it's here, it's been damaged. I would like a partial discount because of the fact that it's been damaged in post, right? And they did come to the party and they did give me a discount, so I did get some money back. But you can see, like here, I've got these squared posts. That's these two posts just here have been pushed into this because it's just sitting on the bottom panel and it's just squashed everything in. And that relates to what I found. So if you look closer in this, see these are the actual capacitors in here, and these are the connections to go to the front panel connections all the way along. Right, so these basically bus systems, and because the panel has been squashed down, it's pushed onto these. So this one here is basically touching the one beneath it. Just about. This one here is touching the one beneath it. Then this one here is actually the 10, which is giving the problems before. Try and flip it over a little bit. So this bus here, if I push it, can you see the one beneath it moving? Maybe you can if I get the angle right. So just there, I push that. See, it's touching the other one. So the casing's been pushed in. It's pushed this rail, this connection, into the one beneath it, and that's shorting it out. So those are the pair for the 10. This two here are kind of, I don't know, it still feels quite solid, but I think that has been bent slightly. It is potentially touching just there. This one seems okay. That one seems okay. But this one is touching. So if I actually bend this back up again, that'll fix that problem. And that's what I found before when I was trying to measure it. The 10 wouldn't work, it shows a short. And I pulled the cover off and I saw these are touching. I thought, right, that's what the problem is. And you can still see the bits of polystyrene floating around from the packaging, which, you know, kind of needs to go really. But it's basically a box full of big capacitors with these big bus rails joining everything together. But yeah, these are the side panels which I need to kind of see if I can replace. But everything's mounted against these side panels, so anything I do to try and get these machined and get a new panel made has to be fairly precise to make sure everything fits correctly. I've got to make sure the holes are in the right places and that sort of stuff. Not impossible, just takes a lot of care. But it looks like most of the job on this is just to make sure that things like this get pushed apart again, you know, separate them again, unbend it, and straighten out the bottom panel. And that will probably be good as new, well, almost, apart from the broken panels. Look like Western 238 jacks. Hey Rory, how's it going? Not familiar with that one. Just going to try and pull this up a little bit. Get some separation. Oh, right, okay, so it's doing that. So the sockets are actually split sockets. This is why I'm having so much trouble trying to get these connections as well. The socket's in two halves, and when you plug something in, it's joining two halves together and makes that connection. So yeah, that's going to be part of the problem with why I'm having trouble with that. That's now not touching. I think this needs sorting out. Be really careful not to break things off the actual capacitors. Is there any problem? Okay, it's looking good. The foam. Okay. It's really vacuuming, I think. That's looking right there. I think that's probably it. That's still a bit close to what I like it now. Got this bracket that goes around there, which is kind of pushing onto that as well. Might need to twist it. There's not much of a gap there at all, I have to say. Kind of need to lever it out and push it at the same time, and not put so much stress on things. Still doesn't feel right. Anyway, it's definitely a gap there now. Whether it's a consistent gap which is always going to stay there, I'm not sure. Yeah, that bottom strap there is also looking a bit dodgy. You know, they all seem to be pushed down, so. Because I'm pretty sure if it's touching that strap as well, it's also not going to be great. That one's certainly touching. We've actually be shorting them out, won't it? So it's just try and pop all those up as well. It's a shame the bottom of the case got shut, staved in like that, because if it hadn't got staved in, all this lot would have been fine. Also got to make sure I don't stick out too far, otherwise the bottom cover will hit it as well, so I kind of be careful not to go too extreme with it. But, yeah. I think it's basically near now. Let's see if we can measure some capacitance on this thing now. I could put some heat shrink in there, yeah. I could just slide something in there to create a barrier. So I've just been going around just trying to bend everything back up again, make sure nothing's touching against each other. These shouldn't be touching together, shouldn't be touching against these straps. It's just because everything's been pushed inwards when it's been hit against the bottom panel. So I'm just trying to make sure that there's nothing touching these metal straps that hold anything together, because otherwise that would be effectively shorting it out. There's gaps over there, there's gaps there. Making sure these don't touch together, these aren't touching together. I think we're just about there. It's just about, I think. If they put spaces in things in the very first place, it wouldn't have been a problem, but there's no spaces. Relied on having things rigid and sitting nicely. Those are all looking fine because they're clear enough of it. So I reckon that's probably going right now. I think I should try measuring capacitance again. Yeah, dielectric constant will be something as well because it is going to be a capacitor. So it is an air gap is a fairly good capacitor. Still, you know, even me moving around is probably affecting the values. Let's see if I can measure them like this. 10. Beautiful. Right. So let's measure the capacitors from the inside, because then with diffing I get good connections. And all I've got to worry about then is whether these sockets we need sorting out in some way. So we'll do this one first, which is the 40. There we go, 40.1. It's measuring it. Then we'll do this one here. That's 30. Yeah. 20. Yeah. 10. Which is one I had the real issue. That's perfect. So we've got 4, which is good. 3. Try and get to the 2 if I can. 2 is there, yep, and 1 is here, which is a bit tricky. There and maybe there. Can you get to it? Is that 1? There we go, there's the 1. So they're all working fine. So no more shorts, at least until I put the bottom cover back on again, which obviously I need to strain out. I'm not going to do that in video because it's going to make a hell of a racket, smacking it with a hammer and that sort of stuff and trying to get it flat. I've done that plenty of times. I've shown it in videos before doing that kind of panel beating work. You just need a couple of hammers and a nice flat surface and just work at it gently and just take your time with it. And you can get those sorts of dents back out and get them almost flat again. If you put enough time into it, you can do quite a good job. So we also have the front panel outputs on here as well. We'll look at those. So I've got these connections, which is 1 and 2. There you go. 100 nanofarad, 200, 300, 400, 5. Yep, those are working good. Now this knob here is actually bent. You can see it on camera or not, but it's actually bent where it's been hit. I don't know if I can fix that. It is part of the chassis mounting. If I can straighten the chassis up, it might be right, but the shaft isn't bent. It's the mounting the shaft is on is bent. And there's a chance that I could damage it further by trying to straighten it. But we'll see. So it's 10, 20. Just making sure they're all working. 90, yep, that's all those. 0 again. So I do have a little bit of a offset there. Can get it down maybe. So 1.5, 2, 3, 4, 5, 6, 7, and 9. Yeah, all the switch positions are working nicely. And then we've got this dial, which means I can actually wind up and down with this. Alright, so that's the lowest point there. So there's 0 there. And I can wind it up from that one, which is obviously just an air capacitor. And it goes round and round and round, so maximum is 11. So there is a slight bit of, I don't know, stray capacitance I suppose. It could be the leads themselves. Yeah, see, that's me holding it. So I've relative that. Put it back in again. Do much lower. Anyway, it's working. So it's just purely because the bottom casing has been stoved in, and I need to fix that before I put it back together. I do want to fix these side panels. This is really bugging me. That's been broken off and damaged. Like I said, I do want to get some panels made for these, and if I do, I'll probably do a second part video, maybe add it onto this. I'm not quite sure how I'll do that yet, but we'll see how that goes. Hey, B-Block, how's it going? Alright. Do you really want me to straighten this thing up on stream? Could be a bit noisy. The top panel is also dented, but not to the same extent. So it's got these little clip things here which you can release to slide the feet out. They're not so bent you can't slide them. This panel's quite soft actually, it's quite good. Go on, slide. This one doesn't want to move. Jammy. Here we go. That's already half out because it's already popped. And so's that one. Looks of it. Alright, panel. Not so flat. Now this panel is quite soft, so a lot of it I can probably just push out by hand. And then, yeah, that's already just changing it. So just by pushing it out I can do that. And then I'll do the sharper bends with the hammer. It's the advantage of being an aluminium panel, I suppose. If it's steel, I wouldn't be able to do this quite so easily. Right. Turn off the mic. No, you want to enjoy the fun of this, don't you? It's all part of the experience. Anyway, yeah, I mean, you get the idea. I'm not going to carry on this in the stream. Yeah. More of that. If I were dragging caps, actually, I don't know. Did it say on the front? I think it did. I thought it did say. No. I don't actually know what a rotary treat is. But the main thing I got, the reason I got this was because I wanted it for the standard capacitors, right? Because you want a capacitance which is a known value. It doesn't have to be exactly right, you have to know what it is. And I thought these capacitors would be really stable and reliable because they've been aged for many years. This thing's dated 1975, I think. So it's 50 years old nearly. So they'll be pretty well aged, pretty stable. headphones. And when I'm doing like multimeter testing, I need to do standard capacitors, and I do actually have standard capacitors, but the biggest one I've got is 1 microfarad is the biggest one I've got. So that's the most I can check with those standards. The reason I got this capacitance standard is because it goes at 100 microfarad, and okay, it's a bit chunky, but it means I can do those kinds of tests. The biggest problem I've got is that obviously I need to sort those sockets out so I can actually plug leads in. Even if I need some kind of data, I might even get like a bolt, find a bolt which is the right sort of size it plugs in, and drill a hole in it, like a 4mm hole, so I can just plug banana plugs into those. I may have to do something like that. There'll be something I'll be able to do to make an adapter to suit that, but yeah, that's what I need to do. But yeah, aluminium panel, much easier to panel beat than steel. This won't take long at all. I'm sorry, you can see me better. Got a drill index? No, I don't have a drill index, but I do have some drills. I could always just try drill bits and see what size seems to fit properly and base it from that. I don't have a lathe this any point. If I had to machine something down, I don't have a lathe. I know how to use a lathe, I have used lathes, but I don't have one. Yeah. Yeah, that's going to come out fine. That'd be fine. That's already considerably better. That hard edge there is going to be the hardest bit to do, but that's not too bad. Or copper. Yeah, copper may be possible. Yeah, anyway, this is not too bad. Yeah, sort of bowed like that as well. That's alright, I can sort that out. It will come right. Okay, that's enough of that, I think. You get the idea. You said no to a resistance check. That's not good. Oh, I said that 10 minutes ago. Didn't see all the comments, obviously. Right, back to that one. Rather thin for a big device, yeah, especially with the feet on the bottom of it. So the feet are in that panel, so it's all that weight on those feet, those 5 feet, and it's very flexible. Not as robust as you think it should be. It's part of the problem. Yeah. Anyway, it's a project for later on. I'll finish that later on. So I've got 2 projects finished. That panel beating, get it all nice and straight. And whilst I've got that part, measure those side panels up some more and get some final dimensions to try and do the CAD stuff and see if I can get those panels made, or maybe some bolt-on panel on the side or something to replace the handles. Something, I'm not sure yet. You know, I could even like step around the side, like a 90-degree corner on it, so I could come up the sides, step around the front panel and come out, so that it hides those broken parts. It's possible. Designed to be rack mounted? Well, yeah, it is kind of. There's no mailbag tomorrow. I don't have one for it. I do have mailbags recorded. I don't have one for tomorrow though. I almost had one for tomorrow, but I didn't bother in the end. I've just been too busy with other stuff. Yeah. Okay, well I think I'm going to call it a day and go and get some more coffee because I really need that, and that's some lunch. And tidy up, get my wife her desk back. So she'd like that. 20 packages the last 2 days. Yeah, I've been buying less stuff for mailbags, so the mailbags are going to be a bit less frequent than they were before. I'll still be doing them, but they're going to be a bit more hit and miss. Whereas it used to be, for years, it's been every Monday. It's been a mailbag, and I think I've missed 3 in the past few months, 3 or 4. So I'm buying less stuff. I think I own everything. I think that's what it is. I think I've already bought it all. So, okay. Well, I'm going to call it a day. So thanks everyone for dropping by. Give us a thumbs up before you leave. And if you liked it, of course. If you don't like it, then don't do it. It's fine. And I'll catch you all another time. I don't know when the next live stream's going to be. I've got some weekend work I have to do coming up, which is why I don't do many live streams on weekends. And I've got some other things I need to work on, such as writing the code for this website. And so I need to prioritise things a bit differently, I think. But yeah, so thanks everyone for dropping by, and I'll catch you all next time, wherever that will be. You'll see.